Good afternoon. I'd like to call to order the Horry County Solid Waste Authority Workshop for Tuesday, January the 8th, 2019 at 12 p.m. Let's have a moment of prayer. Father, we just want to take this time to thank you for all the blessings that you have bestowed upon us. We ask that you go with us during this meeting, keep an open mind, and help us make the best decisions we can for the citizens of Horry County. These and all other blessings I ask in your name. Amen.
Amen.
Lord, if you will lead us in the pledge.
Please stand and face the flag.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
I need to get an approval of the agenda, please.
So moved.
Second.
It's been properly moved in seconds. Are there any questions? All those in favor, let it be known by saying aye.
Aye.
Ayes have it, and the agenda is approved. First item on the agenda is the solid waste recycling grant recommendations. Ms. Esther, is you going to handle that?
Yes, sir.
You notice I went straight,
Yes, sir.
even though I had you here on my right.
Good afternoon. Mr. Hughes, do you want me to go through each one individually and y'all make motions then, or do you want me to do all at one time? It's four of them.
Just, why don't you just do them all four, and then we can,
Okay,
unless you need to have them individual. To me, I just rather do them all four, and then we'll do it at the end.
okay, very good. In your package, you have recommendations on four recycling grant applications we received all during the month of December. The first one is from the city of Conway. They're requesting $10,000 in grant funding for the purchase of additional recycling roll carts, the 65-gallon roll carts. They have roll carts currently in their program, but they're trying to replace 18-gallon recycling bins that they also have in their program. So their money is going towards the purchase of additional roll carts. And this would be primarily for their residential recycling program. The second grant request is from the town of Aynor. The town of Aynor currently does not have a recycling program. They had one that was basically one through the Solid Waste Authority up until about 6 to 9 months ago, and they asked to have recycling containers removed. They said it was too much of an issue with them trying to maintain the containers, the cleanliness and stopping contamination, so they opted to have the containers removed. They're now looking at doing a curbside recycling program within the town. About 350 residents in the town limits of Aynor. They're looking at buying roll carts, which is primarily what the money's being asked for. In addition, to actually start a program, they'll also have to do some public education and have to consider how the material will be collected. Since they don't have a program, there's no collection going on currently. The committee reviewed the application and thought, yes, it was a good use of money to buy roll carts. However, this particular recommendation comes with a contingency that is contingent upon them actually hiring a vendor to do the collection. There's no need to spend money for carts if you don't have a means to collect it. So it is contingent upon them actually having a vendor in place to collect and haul the material. The third application received was from the Buck Creek Foundation. The Buck Creek Foundation is managing the Giving Hope Gardens and Giving Hope Farm. And the mission of this foundation is to help individuals with special needs develop more independence and to teach them a life skill. Their grant request is requesting funds to establish a garden on their property that they own, as well as to promote organic food waste composting. So they're trying to keep a sustainable program So once they grow the produce, they will give the produce to those in the community. And then to remain sustainable, they're going to have on-site composting, which they're going to teach the community to hopefully promote food waste composting also. So,
Question,
yes, sir.
if I may. Could you tell us a little more about Buck Creek Foundation and what they've done in the past?
I might let Mr. Knight give some comments on them. He's had some direct
Not familiar
communication
them
with
at
them.
all. This is,
It's a new group, mainly in the town of Loris. Two people that really, I think, really got it started, got special needs children. One is Dr. Holt's son, and the special needs child is his grandson. Miss Brogdon, school teacher. They have leased part of the old Clarity Nursery and got it cleaned up, which is in the heart of Loris. They've got property out on Old Buck Creek Road that they've gonna utilize too, but from looking at Clarity's nursery prior to them getting started, they've done a great job in cleaning up, got a lot of volunteers, church group, ball teams, and everybody helping it. And what I think they want to do is try to make some neighborhood food recycling that they can utilize there. And a lot of times we have material they can use here for raised beds and stuff like that. And I needed some way too to offset that cost. If they come out and get it, they're way out, and they can reuse some of the stuff that we get here. So I think it's going to be, and I think their main long-term goal is to actually have some housing involved later on for the people.
could you keep us apprised of their progress? This is an interesting
Yeah,
project.
as a part of any grant that's awarded, they do have to complete
If you
a
would let the
bi-monthly
board know
report.
what they're-
Mhm.
I'd
Yes, sir.
appreciate it. Thank you, Dan. Thank you, Mr. Chairman.
Okay, the last application that you should have is one received from the North Myrtle Beach Chamber of Commerce. Their grant application is basically a public education, or educational outreach request for funds. They're looking at developing educational material to, share with the business community in North Myrtle Beach on ways to reduce the amount of single-use plastic being generated. And their target materials would be plastic bags, straws, plastic bottles, things of that nature. It is a public education-based grant request, so the funding they're seeking is funding to develop posters, brochures, things of that nature to share with the business community. They will also go into the community and do presentations to businesses to educate them on the importance of reducing the amount of single-use plastic. They would also be working with the CCU School of Business on the development of the educational material, which we will have approval authority over before they actually produce it. They did not ask for a specific funding amount. Their request was whatever funding was granted, they would use towards reaching out to these businesses. So the grant committee made the recommendation of $5,000 towards their educational outreach program.
Now, are they tied into the city of North Myrtle Beach, or are they doing that on their own?
Nothing in their application indicated that they were doing this jointly with the city of North Myrtle Beach. I know they work closely with their staff, but they're not directly tied to it. And
But the
if,
city of North Myrtle Beach requested a grant too, did they not?
yes.
That
City of
was
Myr-
early on,
Yes, sir. And their grant was for roll carts.
right.
Yes, sir.
Question?
I think that's a good idea. I would like to see them, if they're going to be doing that with business owners, working with the restaurants and the motels to try to work with some of that, I think would be a good idea.
You mean from an educational standpoint?
And to let
Don't
them
know.
know that it would be a good thing. We've been trying to get into some of the motels and restaurants for
yeah.
quite some time. I think maybe the chamber would really have a little bit of influence with that, and encouraging that for them to start doing their own recycling, I think would be a great thing.
Go ahead.
Like the last application, I'd like to see an update of their progress. I'd like to see the materials they're sending out. That's a terrific project.
Yes, sir.
Carl?
Having read the information on the recycling grant recommendations on my wonderful little iPad, and having listened to Esther's presentation here, I move that we move forward and grant the application as requested.
Okay, it's been properly moved in second, but I do have just a few questions before I call for the question. Conway basically was just to get containers. Is that correct?
Yes, sir.
I assume that there is some criteria which you go through in order to look at these, whether or not it's innovative, new, different, or is it just whoever submits?
Every application goes through a review process. As a part of the review process, we have certain criteria they must meet.
Okay,
And yeah, we have certain criteria that they must meet based on the grant application itself. So, for instance, in the application, there are 15 questions that they have to respond to, some of which talk to the actual project description and how is it going to improve upon what's currently in existence. Is it something new? It's things of that nature. So, yeah, each one goes through that process.
okay. And,
You
go
were
ahead.
talking about Conway application.
Yeah,
You know, back when we were doing the rate study, Conway was actually here, and Councilman Tom Anderson and one of the other ones spoke about they had been debating whether to go with bigger bins, and I think this is part of their, the bigger the bin, the more people's
right,
gonna
yeah,
use
this
it
is there
instead of
to
the.
help increase the recycling.
They-
Yeah.
They're anticipating a approximate 20% increase in recycling through the use of the roll cart, because they do have some currently. They do offer 65-gallon roll carts currently. However, they still have some of the 18-gallon bins in existence that they're trying to move everybody into.
And these grants are reimbursable. They buy them and then we reimburse them for their funds.
Okay, I'm just doing an educational for myself. The town of Aner is a new program, I would assume, because they don't have anything.
That's
So it would be new and innovative for them. Now, the contingency thing, when will we know whether or not they have secured someone to do the recyclable?
Once the board approves their application, we will contact them to let them know that it's approved based upon or contingent upon them actually securing a vendor. At that point in time, it will be in their ballpark to let us know when they have a vendor secured.
So do they get the money once after you find that out?
They get the money once they actually purchase a roll cart after they have a vendor.
Okay.
Everything's reimbursable. They've
So
got
if
to
they
spend
don't get
upfront.
vendors, then the money comes back to us?
They don't get any money.
All right, I got the last.
Yeah, yeah.
The Buck Creek, I thought is very innovative. I think that's a great idea to get disability kids involved and that kind of stuff. I thought that was a great one. And the public education, it goes back to what you said, Pam, maybe we could get the chamber involved to doing some of the hotels. I know when I went up to, I guess it was Cherokee, that hotel does recycling of the old shampoos and all that kind of stuff. So that may be something that the chamber may want to look at, trying to get more of these done with this public education. That's all I have. So now I'll call for the question. Any questions? No question? All those in favor say aye,
Aye.
and the motion is carried. Thank you.
Yeah, the only thing I would like to say is to make sure that Buck Creek knows what will be reimbursed and not. I saw a security fence and different things, and I don't know how that would work into that, but I would hate for them to go out and spend money that probably in the early stages they don't have, and then that not meet our requirements.
Any other for Esther? All right, we are now going to look at the MRF upgrade and retrofit, and we will have vendor presentations in a while, but I would like for Mike to take a minute to kind of bring us where we were and where we are at this point in time.
Want to sort of give you all a little background and update of exactly where we're at in the process. You know, we've been working on this project for about 6 months now. We put the project out to bid and got the numbers back in October. And, and got the RFQs back and, stuff. But anyway, a few points I wanted to bring up so y'all would keep it on your mind as you were looking at these proposals. Recyclable material composition has changed since 2008, and so is the equipment that we process it with today because of the makeup of the material, and technology has definitely changed. And in 2008, the equipment was put on the replacement schedule to be replaced in 2019. So we've been setting aside of money since 2008 and have the money in equipment replacement account currently. Replacement funds available is about $3 million in our capital budget account, and we have $600,000 in E-funds for optical sorters. Now, that E-fund money is, has to come out of unrestricted reserve or somewhere else in our budget in the event that we can find some places to get it. So it's not, the money's not physically there. So we got to try to find any money of the $600,000 within the budget. Due to cost estimates, first of all, we looked at first refurbishing the units. We wanted to refurbish it rather than buy a new one. We thought that would be the cheapest way. The first cost estimate we got was around $3 to $4 million to refurbish the whole system and take 4 to 5 months worth of downtime to do it in. So that's when we was looking at refurbishing our current system. Then we felt like, well, let's see if we can put out an RFQ and see what we can get for what money we got. So that's where it put us at now. We know what money we got. We want to see how much we could get, as much as we could get for it, and possibly do some of the refurbishing in-house. Stuff that had to be done, we would do it internally, that we could do to try to save money. After we reviewed the RFQs, we went to about 8 different locations on the East Coast and tried to look at the equipment that was proposed by the vendors that they thought we needed for our thing. After we did that, we come back and told them, well, this, based on what we saw, this is what we want you to put together for us. Made some changes, recommendational changes, and give us those prices back. Well, that's where we at today. We're in the final version of that. We've looked at it, moved it around. And we've worked with the proposals on the RFQ, during the RFQ process to get us what we think we need and can afford at this point in time. Our goals when we started this project was to reduce maintenance costs, less wrapping in the equipment, so we wouldn't have to be in the equipment shutting it down for 1 to 2 hours a day trying to clean it, which would increase production. But when if for every hour it's down, you're talking around 10 tons of material that you could process. We have an issue with our electrical system on the plant currently, so we asked for the whole plant to be rewired to make sure we got rid of that problem. It'll just randomly shut down. It'll randomly fall out, and we know it's a wiring problem. We had electrical company come in and do it, and they found rocks inside the pipes, and it had run wires raw. Over 10 years, it took 10 years to do it, but a little teeny pebble rubbed the wiring to sort it out. So we wanted to try to get it rewired and a new control system put in. We wanted more tonnage, throughput through the system with less rejects coming out the other side. Second, last, we wanted to reduce the labor cost. How do we reduce the labor cost? These are the things we looked at when we were looking at this system. Give you an example, in 2015, prior to Charleston, we were doing about between $8 and $9, or 8 to 9 tons per hour, working a 40-hour week. In 2018, FY218, we done between 10 and 11 tons an hour. Due to the increase in tonnage and recycling that we have within Horry County, I looked at it without Charleston, working a 40-hour week, we would have to process about 12 to 13 tons an hour. So our system, we hoping we get some efficiency because our material is a little cleaner. But currently, we would have to process in some form or fashion about 12 to 13 tons an hour. And when the MRF in Myrtle Beach shut down, our tonnage increased over 6,000 tons a year. So we increased our tonnage at the MRF by about 600 tons a year that was coming, or a month that was coming into the plant. And so all those things we looked at as we were thinking about the system that we were doing. Be glad, I'm gonna turn it over to Felix, let's see if I can get this right, Ottenstein, there you go. That's a good American name there. But anyway, I'm gonna turn it over to him to do, he's with CP Manufacturing. He is currently with our equipment that we have now. And I'll be glad to try to answer any questions if anybody's got anything.
Mike, yeah, any questions?
Anybody's got any questions, any of the board members, jump in and ask him. We'll stop him and get the question answered.
Mike, is my understanding that we have not chosen a vendor yet,
We have not chosen the,
and that we, this is to, you have given them your request, and so we will be looking at equipment that will be conducive to what you want to accomplish.
yes, sir.
Okay. So if there are any questions, jump in.
Let me get him up here.
All right.
Yep, get it, speak right there. Oop. All right, there you go. That's the one that was on the drive. Yep. You got the right one with you? That must have been the first one from the first go-round.
I assume all of you have been at the MRF at some point or another over the last few months and years, so you're reasonably familiar.
A little louder. Talking to your mic, please. They can't hear you.
This one here?
Yes. All right, thank you. I appreciate you us giving the time and the opportunity to present what our proposal was to Mike's group on, the upgrades that we're proposing. And the first thing I would like to do is just, when I practiced this morning, took me about 35 minutes, so hopefully that'll be about it. Give you a quick update of our company, then the flow diagram of the current system and the two options that we're proposing as far as upgrades are concerned. And then I'm going to go a little more into detail on the individual pieces of equipment that we're proposing to either retrofit, to add, or to modify. And then I have a couple of summaries, including projections for staff. That was definitely one of the things that Mike mentioned as well, as far as what the upgrades are supposed to do, as far as, again, trying to improve the quality, not as much recyclables going into the residue, and reduction of manual labor. So the CP Group, As you heard, the system was installed in 2008. We've been a family-owned business for a little over 50 years out of San Diego. We have two divisions. One of them is actual operations division. We do run our own MRF. We have one on the south side of San Diego. It is about a 15-ton per hour single-stream MRF, and so it allows us to get the insight on the operator's challenges and possible solutions, as well as any new equipment or modified equipment that we have. We can test those at our own MRF. And then we have the manufacturing side with about 200 employees, which includes CP as the systems integrator, MSS, the optical sorting division, which is the division I actually work for. Kraus is a systems equipment builder, more specialized on the construction demolition waste, and then Advanced MRF is our controls group. So what we're proposing here would have equipment from CP, MSS, and Advanced MRF in the system. We have been recognized by the Solid Waste Association, SWANA, over the last few years, 2014 through 2016, for multiple design awards. And so it allows us to recognize that, our systems are solid, they do work, and the designs are according to industry standards. All right, let's get into what we have today. This is a plan view of the MRF. Again, sounds like most of you have obviously been there and are familiar with how it works, but just to kind of quickly go over it on the in-feed side, and you can see those green dots, and that comes into play as I go through the presentation, is where the manual sorters are currently in place. So we have the pre-sort with 4. Then the first piece of equipment is the cardboard screen, the OCC screen with 1 QC station. Then we have the combo machine that breaks the glass and screens the glass out and sorts out the larger newspaper, the larger pieces of paper. The glass from this machine goes outside the building. The newspaper that comes over the top of this screen goes to a manual QC station with currently 10 people. Once the large paper is out and the glass is out, it goes to the V-screen, which is the second machine that separates paper from containers. And on the paper side, it's mostly smaller mixed paper that goes into the fiber sort house here that currently has 4 QC stations, and the containers then go on to the container line with a total of 6 sorters, 5 on the main sort line for the plastics, and 1 person on the quality control of the aluminum. There's one more station which I'm kind of pointed out here because it's connected with the residue, but in reality, the person is actually stationed under here somewhere. Currently, there's a very high amount of aluminum cans ending up in the residue that eventually goes out into the compactor, and that person is actually stationed to pull those out. And so that's the additional position. So the total is 26 as of today. Now, the base option that we're proposing as far as upgrades is concerned only, only affects the existing mechanical sorting equipment, so the 3 screens that are there now. And we're either, we're replacing and upgrading those pieces of equipment. And what it means is, the cardboard screen would be replaced. The glass breaker screen, which is currently part of the first newspaper screen, would be separated out and would be its own individual piece of equipment. Then the new screen would be replaced by an anti-wrap screen, and the V screen would be replaced by the CP screen. So I'm going to go into those details for each machine in a bit. But what it'll happen, because these newer machines, again, the old system was put in 11 years ago, the newer machines work a lot better. It'll allow us to reduce the head count by 2 on the newspaper QC, by 1 on the mixed paper, and that last resort person that's currently sorting the cans at the bottom will be able to be eliminated. So you will go from 26 to 22 sorters if it's run at the current volume and with the current material composition. So that's the base option. The second option would be a more automated option, using additional equipment, which would be optical sorters, to generate a cleaner fiber mostly fiber stream that would then require fewer manual sorters. So we would have a optical sorter for the PET bottles underneath the screen here, which will remove 2 sorters on the container line, and we would have a optical sorter on the paper to clean up the paper more, which will reduce the counts on the fiber QC line by several more people, and then you would go down to 13 or 15 sorters, again, at the current volume and with the current material composition. So that's kind of the overview of what is existing and what we've proposed. So now, we'll go into the different pieces of equipment. So we'll start at the front. So the OCC screen is the first piece of equipment. And the main difference between all the screens, and I'll mention this a few times through the presentation, is that the replacement of the OCC screen has a different drive technology. So the older systems have, like on your bicycle, have a sprocket and a chain, and those have the challenge that, you know, they get, you run them all the time, they get loosened up, you have to keep them lubed, you have to tighten them, and then you have to replace them on a regular basis. So there's quite a bit of maintenance involved with that. All our newer screens feature timing belts, like on your car, where you have a timing belt that goes, you know, around the sprockets here. And the one thing that those do, or probably 2 things. First of all, they're a lot quieter. And second of all, they really don't require any maintenance. This, if you go back here on the newer ones, the drive is completely enclosed, and you just keep it closed, and there's really nothing you have to do on those particular drives. So on most of our machines, we have increased the sizes of the motors to make sure they're a little more rugged and can handle a little dirtier material. So there is a little bit more power consumption, 5 horsepower, but the savings in keeping the machine running as far as, you know, parts, again, the chains and what have you, and the labor to keep them tightened and keep them oiled and all that stuff, you will reduce that dramatically. You will not have to change that for, you know, years. It's just self-contained. Because we're just simply replacing the machine or proposing to replace the machine, there's not necessarily any labor savings or yield improvements. The machine will function still the same. It'll just work a lot better as a piece of equipment. The second piece of equipment is the glass breaker screen. As I mentioned earlier, currently the screen that breaks the glass and screens it out is at the bottom of your 3-deck screen here, and it's just 1 deck. It uses those Chromecast discs. We still use those. The main thing that we're proposing is basically breaking this part of the machine out and making it 2 decks. So the 2-deck machine would look like this. It's just 2 decks that would be one after the other. Also, you can see here the deck is horizontal. Here the decks are inclined at about 10 degrees. And what this does, having 2 inclined decks versus 1 horizontal deck, it'll give the material a little longer residual time on the machine, so it's able to shake a little more and therefore remove more glass. You will see, just like now, you will see very little loss of aluminum cans and PET bottles on that particular part of in the system. And like with the current system, because it has that sync drive, so that the drive with the timing belt and not the chains, you will see a vast reduction in having in the maintenance of the drive part of the screen. Breaking the glass hasn't really any labor involved now, so that's going to stay the same. The yield is going to be improved because you're going to, with the 2 decks, we're going to remove more glass. So again, there's a little more shaking going on, a little more residual time, so more glass will be broken, so more glass is removed, which also means, you know, cleaner fiber and containers, and also a little less glass that ends up in your baler because it's not in the fiber or the containers. All right, so from after the OCC screen, the glass breaker screen, now this is the new screen. So currently, that is the first screen that separates the 2D fiber from the containers. And currently, that's this inclined deck that you currently have on this machine. And it's the one that uses those finger discs, and it has the challenge of getting wrapped a lot of the plastic, the bags and the VHS tapes and what have you wrap around there and cost a lot of downtime, as you just heard from Mike. So what we have as a new machine is our anti-wrap screen. And what happens, the challenge with these, the reason why this wraps so much is that the length of the bags is longer than the circumference of those shafts. So as it kind of goes, excuse me, as it goes over the machine, it starts, you know, it's long enough that it'll just start wrapping around. And so the solution to that is making the diameter of those shafts and those discs bigger, and therefore making it a lot harder, kind of like going from an axle on a car to an oil drum, if you will, where on an oil drum it'll be a lot harder for something to start wrapping around just because the diameter is so much bigger. So this is the same concept. Mechanically, still, the two-dimensional newspaper material will go over the top, and the three-dimensional material will fall to the back. That still remains the same. But you can see the diameter on this picture here. The diameter of these shafts are quite large, and the discs that we're using for them are quite different now as well. So again, you remember currently there's those finger discs. Those fingers have not very much surface that can actually touch the material to move it up, excuse me, move it up the screen. So, and with these elliptical discs, that helps a lot by adding more surface area to start moving the paper up and having the containers bounce down. So this is kind of a shot from the top. Again, the diameter of the shafts are very large. As you could see, the discs are elliptical, so this is kind of elliptical egg-shaped here, and then more clocked or turned 90 degrees here. So what that does, it provides extra agitation. So as the material just doesn't, we call that surfer. So you may have seen this on the cardboard screen. Sometimes there's a big piece of cardboard and there's a big piece of paper or a plastic bottle, and it just kind of rides over the top. And so with the finger screens that you have now, or the finger discs, it can happen that stuff just kind of rides up and surfs up the top of the deck. And with those elliptical discs, there's actually a lot more agitation, and so there's less of that, which again improves the separation part. One of the other things we're proposing is using a wider model, so that'll provide you a little more throughput. The shafts that you saw in the picture, so these right here, those are not actually the shafts, so there's a sleeve around the shaft, so the shafts are protected from any heavy material that might hit it. Let's say a tin can that might have some nails in it or something like that.
Question here, if I may.
Absolutely.
Will this eliminate the problem of jamming, or does it simply decrease it?
It'll, because the diameter is so big, the only place where you will have still a little bit of wrapping is on the very last one, because here in between, it'll just kind of keep riding, but on the top one, obviously, it's not keep riding, it's going to fall over the top, so some pieces might still wrap there, but it'll go down 90% easily. I mean, there's a very vast improvement of those. So one of the things I wanted to mention, and that's both on this screen as well as the next one, we have an integral a safety platform. So if you have to go in there, there's actually, you can walk in from the side into the screen here. And there's a platform that folds down and is safe to work on it. As far as, again, to summarize what the effects or the impact on the facility. So we have less power. The existing screen has I think, three motors. This one only has one. So there's a little less power. And the maintenance, the labor on the wear on the discs is probably going to be about 70% lower. Or if you have, let's say, $1,000 today, it'll be $300 once the new screen is in. So, and mostly that is because the newer discs have a much longer lifetime than those finger discs. Because it works so much better, we will have a labor savings, be able to remove a couple of the QC people on that fiber line. One of the other things that it will do, because it works better, the yield improvements, again, when I was there just watched last week as far as what's going to the residue line, because these screens work so much better, there'll be a lot less fiber going into your residue. And And then, of course, the output quality, because it's getting better, you can save the labor. So that's just kind of a summary there. Now, the piece of equipment that has probably seen the most improvement as far as operational efficiency and a reduction in cleaning is the V-screen. Back at the time when this was developed like 15 years ago, we thought this was going to be the solution to everything. But it's definitely a maintenance and operational intensive machine. And so what we have now, what we offer now, is what we call the CP screen. And it's similar as far as the mechanics of it, like the anti-wrap screen or the newspaper screen that you have now. It's an inclined deck, a steep inclined deck, and the overs is the mixed paper, and the containers fall off the back. So that's the same. The design of the discs is actually the same as on the glass breaker screen. So it's these clocked elliptical discs as well, just smaller for the smaller material. But these are made out of rubber, again, to make the maximum traction. As you can see, they are kind of clocked here with the ellipticals. So again, that gives you a little more agitation side to side, not just up and down. And so one of the other things, just like on the glass breaker screen, the discs actually cover the shaft. So the shaft is protected. So again, something heavy were to hit it, it's actually hitting a disc first and not the shaft. So there'll be very little or no shaft changes necessary. The rubber discs themselves, as far as replacing them, they are built like a two-piece clamshell, so they just come apart like this. And one person can actually change them from the top of the deck. There's not the requirement where you might have a person from the top and one from the bottom trying to fix it. So it really, it's really very straightforward to maintain it. As far as the impact on, going back to the same list, so because the V-screen has obviously motors, but it also has air support, so it has some blowers that are built in. Those are not required in these newer CP screens, and so there's less horsepower. As far as the discs, the savings on the discs themselves and replacing them and maintaining them is similar to the anti-wrap screen, about 70% less. And because they are working so much better, you'll be able to save QC personnel on the mixed paper line. Because they work better, you will have, again, so much fewer pieces of aluminum and PET and fiber going to your residue line. So, I mean, from the installations that we've seen, or especially what you have now, the amount of aluminum cans that even enters the residue stream, it's going to be significantly less. The other thing that happens is because they work better, you will have less fiber on your container line. The sorters on there might have, you know, if there's for some reason a glut of paper or it's contaminated, it's more difficult to see the bottles to actually sort them. So if you have less paper, it'll make the job for the people that are still working on the sort line a lot easier. All right, so this ends the part of the presentation of the base bid where we're really just replacing or making recommendations to replace the existing mechanical sorting pieces. So now the second part is talking a little bit about the additional equipment that could help reduce the manual labor, which is the optical sorters. So I'm going to talk first about one that we propose for sorting the PET and then the one for the paper. The core part of the sensors is the same between the two machines. They're just in a different packaging, if you will. They look a little different, but the inside, the scanning is the same. So this is what one of these plastic optical sorter looks like. Mechanically, it's actually somewhat similar to the eddy current separator that is currently in the facility, because you have a wide belt that runs pretty fast, and you're trying to spread the material out, and it runs through, and the machine makes one, what we call a positive sort, just like on the eddy current where the aluminum cans jump across. And in the optical sorters, we use compressed air jets to blow the targeted material, and then whatever's not sorted just kind of, you know, runs on the conveyor and falls through. So that's the way it works. The sensor housing on top illuminates the whole the width of the machine and looks down and identifies the different pieces: PET, HDPE, paper, cardboard, whatever. And then in the operator interface, you tell it what should be sorted out, and it'll blast those out, and whatever's not targeted just falls through. And So there's a picture of a couple more. Again, they look very similar. The actual sensing technology inside is called near-infrared spectroscopy, so that's a technology that's been around for a long, long time, but it allows us to identify the different types of plastic, whether it's a plastic or not, and then, you know, you, just like with your camera, you can see the individual pieces, and then you can sort them out, or not sort them out, depending on what your application is. In yours, the labor on your plastic sort line, the most labor is on the PET side, so that's where normally, or in almost all the plants where an optical sorting is put in at first on the container line would be for the PET, because it requires the most sorting labor. I've been with MSS, the optical sorting division, for over 20 years here in the US and over in Europe for 3 years before that, and I cannot tell you how much more efficient these machines have gotten over the last 20, 25 years. So we are easily above 95% now as far as what's targeted and what's being removed. And so these have become, we're putting in, especially in newer facilities, we're putting them in everywhere. Couple of the things I wanted to talk to you about, obviously it is a newer technology and requires, it has sensors, it has computers, it has electronics. So again, for those who are, you know, concerned as far as software upgrades and remote support and everything, so these are built, designed, developed, and built in Nashville, Tennessee, and which is where I'm located. We have software upgrades come probably, you know, once a year, every 2 years, depending on if certain advances we make. Those are always available for free. Any remote phone or Ethernet support, the interface that your operators would work with are Windows-based computers, so that can be networked just like any other computer. We provide unrestricted access to all the software on the machine. Some of our competitors start charging at a certain point. We always think that that should be free and unrestricted to anybody. One of the things that is different from almost everybody else that we provide is that the sensors do use halogen lights to illuminate the material. So there's bulbs that are similar to, like you may have a shop light that has like one of these tubular halogen lights in there. And so those will have to be replaced, you know, once or twice a year. They're pretty cheap, a couple bucks a piece. But sometimes, and the machines use air valves, compressed air valves. So that's a wear item, so that will, if you have good compressed air, you may have replaced, you know, maybe 5 or 6 a year or so. But one of the things that is different in our machine is that to replace those, most everybody else, you have to climb inside this hood to replace a valve or a bulb. And in our case, you can do everything from the outside. Like the valves are actually outside or accessible from the outside, and the same for the lights, where with other vendors, sometimes you have to climb inside the machine here. So what it does, first of all, it's faster to replace something, and also it's much safer if you don't have to climb in, especially if there's like some chutes down here that just go into a big hole where there's not a conveyor underneath. So that's one of the things that we've worked on, trying to make it safer. Because we're in Nashville, we have overnight availability of spare parts for those optical sorters, so that should be an easy thing to do. Obviously, because it is an additional piece of equipment as far as the overall plan is concerned, there is obviously some power required, extra power required, but it will save you 2 people on the sorting of the PET. So that's the plastic optical sorter. We call it Plastic Max, and then the second one, which is probably the one that would save you the most amount of labor as far as the number of people is concerned, is our FiberMax. So that's the optical sorter that will clean up your paper. And we have some pictures. This is one out in Seattle, and this one is Mike and his team went to go visit. This is at Sunoco in Raleigh. I'm not sure if one of you went along or not, but they have installed one. And this is actually a similar, as far as the flow of material, to what we're proposing. You have the new CP screen right here, and then it feeds the optical sorter, so that the two-dimensional material, the fiber that went over the top, goes right onto the optical sorter for cleanup. You can actually see the halogen lights right here. And what we do as far as actual sorting, so we target anything that is not paper. So it'd be plastic bags, bottles, aluminum cans, whatever might make it over the top. And then, of course, and that's optional, whether you want to sort out the cardboard or not, you can do that as well, so. One of the things that is different from on the fiber optical sorter, on the FiberMax, is that the conveyor runs a much higher speed. It runs twice the speed of the regular the optical sorters for plastics. As a reference, again, if you're familiar with the eddy current at the MRF, let's say your sort line, on your container sort line runs maybe 100 feet a minute, between 50, 70, and maybe 120 feet a minute. The eddy current that sorts the aluminum cans normally runs 250 to 300. The regular plastic optical sorter runs 500 to 600 feet, and then the paper sorter runs at 1,000 feet per minute, so it runs really, really fast. And the main thing is that we don't want, because it's at the end of the line, we don't want it to be the bottleneck of the material. Paper is very fluffy. As it goes over the screens, it opens up, and it covers a lot of surface area, and so we don't want it to, for the material that we're trying to sort, to be covered up or be around too much other material. So we're trying to spread it out, we're trying to speed it up so that we can have as much of a single layer of material as possible. From some tests we've done at one of our first units in Las Vegas, they can do actually sort up to 2,000 pieces a minute that we've recovered, so that's equivalent to about 40 manual sorters if you run it at full blast. And we have had the region of Niagara in Ontario has actually brought in, they put in some of our competitors' equipment, and which is one of the companies that's bidding here as well. And they've come in and brought a third-party engineering or consulting company in to do some testing on how efficient it actually was. And based on the testing that we've done internally, our efficiency of removing the cardboard is over 80%. Theirs was 67%. Our plastics were at 92%. There was at 53%. And of course, the loss of fiber as well was much higher. So, and we think we can attribute that really to the speed of the conveyor, to that 1,000 feet a minute, where we can make sure that the sensor actually sees everything that it's supposed to see and then sort it out accordingly. Again, because it is an additional piece of equipment in the overall layout of the plant, it requires more power, but it'll save you, manual sort labor quite a bit. One of the other things on the optical sorters that I wanted to mention that we've started using quite extensively is that because the optical sorters are measuring the material that goes through, or all the material that goes through them, so on the plastic side, it's basically everything that goes through the container line. On the paper side, basically everything that comes off that last CP screen, we can actually measure what the material composition is. And this is a screen from one of the plants I recently was over in Australia, and we were measuring the amount of fiber. You can see here this beige orange color here versus the different types of plastic. So this was the first machine on the container line, and as you can see, like almost half or about half of the material that went through that machine was actually paper. And you can kind of hopefully see that beige line here as this is like an hour worth of operational time. It kind of shows how it fluctuates up and down, and you can see the different plastics here. What this tells you is that hopefully, say, wow, there's 50% paper in my containers. Maybe I should do something with the machinery upstream that generates this contaminated container stream. So the information from the optical sorters, whether on the paper side or on the container side, allows your plant operator to say, hey, for some reason, over the last 15 minutes, there's been a lot more paper in my containers. Maybe I should go look why that is. Is it the input material that's changed? Has the material gotten wet? Has it, something has changed in a screen setting, or something has been blocked or blinded or something like that. So the statistical information, which by itself, that's part of the machine, so there's no extra cost to this, but it'll allow your operators to say, hey, there's some extra contamination, or all of a sudden there's a lot more HDPE for some reason. Maybe that may require some investigating why that is, and then corrections could be made to the system if required. So that covers the equipment, the new equipment for the base bit, again, just a mechanical piece of equipment, and then the two optical sorters as far as what I call the automated bit. There were other services that were part of the bid or that came along as we went along in the process that Mike described. One of them was to refurbish any existing equipment that was affected by the retrofit, whether, a conveyor was shortened or was moved around, then we would retrofit those, including the eddy current separator, put a new shell and a new rotor in so that it would function better. As Mike mentioned, rewiring the complete facility to make sure that all those ghost and intermittent electrical problems are eliminated, including fixing the Wi-Fi, which has caused some problems. Plus, in addition, converting the all the conveyors and all the drives to be controlled by a variable frequency drives instead of just some of them right now are still on fixed motor starters. Because what that allows, if you have all the VFD information, you can actually measure the amperage on each motor, and you know what it's supposed to be, and if for some reason it starts going high, and a motor may be running hot, maybe something's wrapped around somewhere, then it'll actually tell you immediately, and you don't have to wait until a motor burns out. So these are some of the the screens that you have. If you gather with the newer software interface, there are systems available as an option that would, you can tie in the information from your balers, from your compactors that give you a little bit everything else that's going on in the plant. And then, of course, daily operator reports. So these are all part of the new the controls package as well. All right. One of the things, as always, is and that was in the bid list is important, is the time it would take to complete such an upgrade. So from, again, estimated is about 24 weeks from receiving a down payment to commercial operation. The projected shutdown times, so obviously the optional bid with the 2 optical sorters, more equipment, so it would require a little more downtime. So there's a couple of options. One of them for the base bid would be basically a 10 days continuous shutdown. So you basically shut down for 10 days, do all the retrofits and come back. Or if you're not able, for one reason or another, to accept that long of a shutdown time, it can be done over multiple weekends where, you'd work Friday night till Monday morning and then run the plant till next Friday to Monday morning kind of thing. So obviously this has the advantage that you would have very little actual processing downtime, but it costs more money because you have to remobilize equipment and workers to come in and do those retrofits. And then similar with the additional 2 optical sorters, obviously, again, more days continuous shutdown and more weekends in case that would be the option to do. All right, I'm basically at the end. I just wanted to, as far as overall, just the advantages of upgrading the equipment and the design, the way we talked about it. Just wanted to make sure that everybody was aware that safe maintenance access is guaranteed to all the new equipment that would come in. Underneath, the equipment would be built up like on the upper level, just like most of it is now, and we would guarantee the forklift access underneath, which is there now as well. The latest design for the one with the optical sorters has a couple of reversible conveyors in there for a little bit more operations flexibility, so that if you needed to bypass a machine or a conveyor or wanted to get all the mixed paper together with the newspaper, depending on how your markets change, that would be an option to do as well. The disk screen, those sync drives, again, the timing belt drives and the rubber discs will provide reduced maintenance, and so from an operations standpoint, you're not going to have as many maintenance hours on the drive portions of all those screens. And the VFD-based system, once it's completely rewired, will, again, from an operational standpoint, will allow you more real-time monitoring of what's going on, again, if maybe a motor is running hot or not. On the cost-saving side, and I have one more slide after this that kind of projects the labors for the different, the staffing for the different scenarios. The new disc screens have a lower dollar per processed ton, mostly because the discs have to be replaced a lot less, and the timing belt drive reduces the maintenance on those units. And of course, the optical sorters, and we'll see that in the next slide, saves the manual
Steve,
labor.
talk a little bit about the life expectancy of the optical sorter and what has to be done to it during that life expectancy?
Yes, absolutely. So most, again, just like here, you said that, you know, when MRF was built in 2008, and then now it's 2019, that, you know, projected, you know, 10, 11 to 12 years. And I would say around the industry, that's probably an average lifespan of separation equipment. As far as the optical sorters, we still have some of them in, as far as maintenance concerned, it's basically a fast-moving conveyor. The sensor, there's, you know, there's on the sensor itself, there's basically no maintenance required. You have, again, halogen lights and some windows that need to be cleaned, but we have optical sorters that are still out there after they're 15 years old. And, you know, they work. They don't work all that great because they're so old, but they still function. And so, I mean, I would not see any issues with running these pieces of equipment for 10, 20 to 15 years, no problem.
Do you, software updates, because we know technology changes, what has to happen to your equipment?
So I mentioned the software updates earlier, again, that we provide those for free. Once the system is installed, as I mentioned, it's, the operator interfaces are Windows-based, so there can be networked through an Ethernet connection, and we can do all that remotely. There's no, if there is an update, we can do it all remotely. We can help you with troubleshooting, or let's say there's a new container, a new PET bottle with a new label that for some reason when it was set up, it's not identifying it properly. We can do all that remotely with your help, so.
Is there a cost?
As I mentioned, the remote service support is always free, so there's, if
I'm
you had,
talking about software update.
that's always free. Yeah, software updates, we don't charge for those. Yes, sir.
I was a part of the group that bought the equipment that was over there, and I know what we were told then, that the replacement of the disc would cost. It has
Okay.
cost us in the last 10 years considerably more than that. Let's pick a 10-year program, same volume we're doing now. You say the rubber's gotten better, everything's got harder, but we're still working with the same product, maybe a better product, but it's sort of kind of the same system. What would you say that the disc replacement per year will be under this system? Cost?
Well, again, I'm not the complete expert on the disc screens, but from everybody I've talked to, because that was one of the things that Mike mentioned, that, you know, that was probably one of the questions that was going to come up, and that's why I put that, you know, 70% number. So it should be significantly less of what it is now. So if there is, you know, $10,000 now, it should be, you know, 70% of that once the new stuff is in. So.
It's hard for me to buy, should be. I mean, I would want somebody to tell me, yes, we've tested it, this is what it is, this is what, I'm not gonna be exact, but should be is a hard thing to put my faith in, because we were told what it should be when we bought the system.
Yep.
And it came out to be more than that.
Yeah, obviously I wasn't involved at the beginning, you know, and when the system was sold, so I'm not sure what numbers were provided at the time. Again, these numbers were just the ones that I was told that we should be, you know, safe to propose, that these are the savings that are going to be there. So I guess that's all the statement I can make.
Mr. Jones, I think we can get that answer to your question. If he doesn't know it, we can get that.
I know there were some emails exchanged yesterday, I think Richie, right, about all the cost on, as far as our service support as parts and labor was concerned over the last 3 or 4 years. Yes. And so the discs were part of that, and I didn't go through and actually divide out how much was discs and how much was not discs, but so they should be able to provide you those numbers, I'm sure.
Go ahead. The nature of doing an RFQ rather than an RFP was tell us you have the expertise rather than us telling you what our needs are. But we chose the timing, we chose the budget, and we have an existing facility which we're trying to adapt. Those were 3 requirements that were outside of your ability to change. Is there any technology on the horizon? that would revise your proposal if we were asking you to give us a proposal a year from now? Is our budget limited so much that a 20% increase would yield a completely different proposal? And third, is our current line function still the best way of configuring the equipment?
Yeah, I would, to your last question, I think that's true for lower volume systems such as yours. I would think that the current, general flow of material and, concept of the plant is still state of the art. You're trying to get the large cardboard out first, the glass second, and then separate the paper from the containers and then sort those after that. So that's still, the way things are done these days. And will be over the next few years. The one area, and again, if you go after, trying to maybe save manual sorters, one of the things in that hopefully over the next, 3-4 years will become more prevalent is the use of robots for sorting. And especially in your case, where the volume is not, by the time the PET is out, there's not all that much volume, and you maybe have 1 or 2 people, sorting the rest of the plastics up on the sort line, that would probably be a place to do something like that. So.
But you don't see any technology on the horizon that would dramatically change?
I don't think so. I mean, if let's say the PET sorter, the optical sorter is 95% efficient, and in 3 years it's 98, it's not going to change like dramatically of what.
We chose the timing of this, and we also told you how much we were willing to spend. And I just wanted to make sure that we weren't shorting ourselves
Sure,
by
I understand.
plugging you into confinements that would be disappointed in the results later.
Yes, no, I understand.
Thank you.
Sure, absolutely.
If we wanted to go into robotics in 5 or 6 years, would any of that fit in with the equipment you have now, or would it have to be totally different?
No, it would, the ones that we're working on or people have put out there, again, when you guys visited facilities, you may have seen 1 or 2 already. In our professional opinion, they're not quite there yet. They're not fast enough, they're not good enough quite yet, but again, things move fast, so. But the goal definitely is to make those retrofittable to whatever plants there are, whether on the paper side, whether on the container side, because we can't go in and completely upend, the 250 MRFs that are out there if it's a new plant, then you can design, maybe leave more room, but the idea is that they would be retrofittable to existing plants. So maybe a sort cabin would have to be modified or something, but not like conveyors moved around or anything like that.
I thought I saw in the list of things that your optical sorter would sort out was the foam or propylstyrene.
Mm-hmm.
So it does sort that.
If you would like to, yes. I mean,
Okay.
it can be programmed to do that, so.
Okay. Well, I had just seen where they just opened a plant that they're going to commercially do that, even with food waste in it, that they can do it into a liquid. And
Okay, yes.
that plant just opened in 2018, so I just wanted to make sure that could do that.
Yeah, I mean, the way it's designed right now, as I mentioned, the mechanical function is similar to an eddy current, so it generates one positively sorted material and one negative, that's everything else. So if you would like to sort the PET, well, it'll just sort all the PET. If you would like to sort the polystyrene or the expanded polystyrene, then you can do that. But if you do that, then you can't do the PET because you don't want to cross-contaminate your PET with the polystyrene. So you would have to kind of make a decision, do you want the one or the other?
It's still either or.
That is correct. Again, you can, in theory, you can sort them together, but that's not going to make a product that you can sell, so.
Is there a sorter that would sort all of that separately, not just 1 or 2 things?
It would, but it would require, another silo, it would require more conveyors, so it would add cost accordingly. And again, based on from what I've seen in some of the facilities up in Canada mostly, where they've added, they on purpose collect the expanded polystyrene, so it is, kind of floats through the whole facility there. Yeah, it tends to end up on the container line, and there's normally one person sorting that, so. Again, whether that's worth doing or not, that's a separate question, obviously, but from a technical standpoint, again, many things are possible, they just may add a lot of cost. So. So maybe I can just go as a summary. So these were the different, the projections on the manual sorting side as kind of the last slide. So right now, from when I talked to Rodney yesterday, he mentioned that, you know, they're running about 12 tons an hour, and we have those 26 sorters that I mentioned earlier. If we run the system with this, at the same throughput, with approximately the same material composition, with the base retrofit, so just replacing all the mechanical pieces of equipment, the screens, we'll end up at 22. If we automate it with the 2 optical sorters, we're going to go down to 13 or 15. And then as Mike also mentioned, so if you went out and got some more volume from somewhere else, and you might increase, you know, the volume 16 to 20 tons per hour, that's very well possible, then we would think that basically you staff back up where you are today, and then with, you know, more or less the same number of people, except the last resort person, you'll be able to do 30 to 50% more volume on the same pieces of equipment. And again, in the automated version, it's obviously quite a bit less. Then the other way you could go is if you say, okay, now, again, then maybe the Charleston volume is not there anymore. So then there's the question, well, if we have fewer tons, do we run at the 12 tons per hour but fewer hours, or do we run more hours with fewer people? So that's kind of an operational decision or calculation that you'd have to look at. So if you drop it down to 6 or 8 tons per hour, then, you know, your number of sorters, you know, obviously drops quite a bit as well, because, and mostly that's all on the fiber side, because it's going to get cleaner and you just have to do fewer picks to sort through, you know, 30 or 50% lower volume. So that kind of gives you just an overview on the savings on the manual labor side. I also, just for reference or to everybody to remind, as far as the power usage, so if we just replace the existing equipment, so the mechanical portion, the base bid, because there's a few fewer conveyors, plus a couple of the screens use quite a bit less horsepower, so there is fewer electricity required. If you go to automated side, because we're adding the optical sorters, which also require an air compressor, you're going to use more electricity if that all were to be
And
installed.
it has a lighting load as well.
I'm sorry?
Has a lighting load as well. All the optical scanners have lighting.
Yeah, the lights are, yeah, again, as far as the horsepower, the most horsepower is from the air compressor. That's going to use, out of that, you know, that swing from minus 25 to 75 horsepower, out of that 75 horsepower, 60 is going to be your air compressor, and 15 is the conveyors and the lights and whatever have you. So as far as electricity is concerned on the optical sorters, the compressor uses 3 to 5 times as much as the actual optical sorter itself. But yeah, that's it. So I hope I didn't confuse you too much and didn't use too much technical jargon here. So, but yeah, if there's
What
any-
kind of payment schedule would you expect?
Mike, I'm not sure what.
What he's talking about is how much you charge.
Yes,
Talking
yes.
about, remember how much you
Yeah,
get
yeah.
up front.
Yeah, when do you expect your funds?
So the first, and to be honest, I have not seen what was proposed in the original RFP as far as payment terms is concerned. But normally there's a smaller down payment, 15 to 20% to start the project, and that normally scheduled. That starts the engineering portion of it. So it'll take, let's say 4 to 6 weeks for the engineers to design everything, and for your staff to then say, okay, this is what was proposed, this is what we're actually building, we're signing off on it. Once that happens, then the actual manufacturing starts, and then there'll be another payment then, because we have to go buy actual components and then build it. And then as trucks start leaving our facility and arrive at your facility, there'll be payments kind of due as that goes along. And then there's normally payments once the installation is finished, and then there's normally a holdback to, that the performance is what it's supposed to be, and then there's a final payment after that.
Typically, that will be determined in the contract agreement. When you get to signing the contract, you'll negotiate what that term is and how that'll be paid.
Thank you. Are there any other questions?
I got a question for Mike. You talked about downtime. What's going to happen to all the material that's accumulate while it's shut down.
Well, as y'all are aware, we have a small sort line with an American baler. And what we would try to do is run enough hours to run our fiber with that. And then the commingle mix that's come in and stuff, we would bale it. And so you're talking somewhere in the neighborhood of about 1,600 tons that you'd bale it over a 4-week period.
Yes.
You said there were approximately 250 MRFs in the country. Of that, what percentage would you say is this based on this type of
Yeah,
technology?
the smaller ones, so, you know, I would, it's probably the majority is smaller. I mean, I'm gonna say anything under, let's say, 20 tons per hour is probably the majority. I mean, the big ones, you know, 50 tons and more, is not that many of those. I would say, you know, half of those are of
And
your
this is
size.
the most predominant technology that's used?
Yeah, I would think so, because again, in communities like, you know, your size, they're kind of, you know, sprinkled across, yeah. Again, 20 tons per hour and less. I mean, yours, you know, there's much smaller ones than yours, you know, 5 tons an hour, but, you know, the equipment to process 5 tons an hour is almost the same that you have to do 10 or 12 tons an hour, so a certain size is required, but yeah, this is a very, you know, standard size that we.
What volume would we need to be doing to get to the next stage of production level?
Yeah, the next stage, you would probably have to go to 25 tons an hour, I would think, so at 8, you know, at 200 tons a day-ish, that level.
When we looked at going any higher in tonnage, we start running out of room inside the facility.
Oh, absolutely, yes.
One reason for asking that is we're going to see a tremendous increase in population as projected. And within 10 years, we're going to exceed the level that we're currently processing, or we're going to have to find another alternative.
Mike, you still run one shift now, right?
2 shifts right now.
You do 2
Through the end of the month.
I'm sorry?
Through the end of the month, 2 shifts.
Okay. I mean, that would be, you know, if you wanted to start increasing, then you know, instead of, again, expanding the building or adding building space or you know, a covered area for bales and incoming material, you know, then just operating more hours is probably the way to do it.
Once you load the shifts out, then the only option is to, you know, to increase the building size. In other words, if we went to a 20-ton per hour system, you know, you could be doing 1,600 tons a week. So you get up to 600 or 700, 7,000 tons a month compared to the 4,500 we're doing currently, just on 2 shifts. And once you got past that, and there are plants out there to do way more than that, and we saw some of them, but you get past that, and then after that, you're done.
Okay, we're getting short on time here, so we're going, if you got some more questions for Mike, we can catch up with him at any point in time.
Yeah.
You got any more questions for the rep?
Just one comment for this gentleman up here.
Okay.
I tend to agree with Mr. Jones. I make decisions based on actual monies. If I bought a car and I was supposed to get 32 miles per gallon, and then I get stuck with it and it's 22, if you're telling me your discs are going to cost me over that length of time 20 or 30,000, it cost me 160,000, then I've made a bad decision based on what you've told me.
Sure.
So I definitely, not only you, anyone else that comes in here, when it looks at maintenance or what it's going to cost me in the future, those are reasons I make decisions, and I want to make sure those are pretty close to what they're supposed to be. I know
Sure.
you might have a few seconds here, there, or more, and that, but there needs to be some kind of warranty or guarantee if we're going to go over a certain amount of that for whomever.
I'll be happy to get with my team and provide Mike maybe some more information from some of the other facilities. I mean, the numbers that I mentioned are based on, you know, machines that we've put in, and those numbers, how many times they have to replace them. But I'll be happy to maybe put a little bit extra information together on that.
Well, thank you. And I agree with that, what both you guys are saying, but what we've taxed Mike in, and when he gives the final proposal, that information will have to be available for us to consider that. And I think Danny has already agreed that he will find out that replacement cost so that we'll have some general concept of what is, no science is exact, but we will try to get as close as we can to what those replacement
And
things
again, we
may
have
be.
the numbers from, again, the last
Right.
4 years or so, we have those, so
Right.
we'll be able to go off of those.
Warranty, what's the warranty on the equipment?
So On the stuff that are not wear items, it's basically, it's 12 months or 4,000 operational hours is the warranty on the equipment.
Okay, any other questions?
That's part of the contract,
Okay.
absolutely. All right, absolutely.
Thank
Well,
you.
thank you for your attention, and again, hopefully nobody felt too much.
We want to, Mr. Chairman, we want to take a 5
Yeah,
minute.
let's take a break, yeah.
Angle with Machine X and Brad with Machine X. They'll be here to do this presentation. Some of you have met them at conferences, and we've all had to put up with them at one time or another. So, Rusty, I'm going to turn it over to you.
All right, thank you, Mike, I appreciate it. Good job. Oh, do I need to speak in the microphone? Oh, okay, interesting. First of all, I'd like to thank the Academy. I'm just kidding. No, yeah, just kidding. Seriously, we do want to thank board members, staff members from Solid Waste Authority of Horry County for having us here. We appreciate being a part of this process. We deal with municipalities all over the country, and this process is different, and we appreciate this process. I don't know if the Solid Waste Authority was set up on purpose like this, but we appreciate it, and we want to thank you for that, because dealing with strict municipalities at times can be challenging, and this process has been something that we've been very excited to be a part of, and we appreciate you having us here today. When you put together a presentation like this, and you're dealing with people from different backgrounds and different interest levels and whatnot, we're trying to give you the information that you're looking for without going too deep into the weeds on the technical side. Because I know that many of you are sitting here thinking, okay, I got two questions on my mind. How much is this thing going to cost me, and what is it going to do for me? What's it going to save me at the end of the day? So hopefully, as we go through here and I kind of walk you through what we're doing, we're gonna answer some of those questions for you. But first of all, before I get too far, I want to tell you a little bit about who we are. As Mike said, my name is Rusty Angel. I'm the Eastern Region Sales Manager. I cover from Maine to Florida, pretty much any state that touches the Atlantic. Brad Goins here is my colleague. Brad is our engineer. We're both out of the North Carolina office, and Brad handles project engineering for us prior to a sale. We have another group of engineers and project managers that handle projects after a sale is made, and we bring it in-house to sort of usher that project through. But Brad handles the design and layout, and as we go through this today, this is Brad's work that you're going to be looking at. If you're not familiar with MachineX and who we are headquartered up in Quebec, Canada. We've been in business since 1970. We started out primarily building agricultural type conveyance equipment, conveyors and augers and stuff like that. Obviously, when recycling started getting big back in the 90s, we started getting more and more requests for conveyors and screens and these kind of things for recycling. We built our first MRF in 1999, and then we built 2 or 3 within the next year or so. Escondido, California, Greensboro, North Carolina were some of the first MRFs that we built back in the late 90s and 2000. We've got, in fact, this number has exploded to over 250,000 square feet of manufacturing space now. One of the unique things about MachineX is that we manufacture just about every single component. We don't buy anything out. What you're going to see today, everything that we have proposed, we build. So that means not only are we in control of the manufacturing process, the project management process, better than a lot of companies, but we are also in control of the service, the spare parts, the knowledge, the research and development of that product, the improvement of that product over time is all taken care of under one roof. We've got over 350 employees. We've got 40 just in our engineering department alone. A lot of times what those men and women do are they are literally sitting around drawing every single manufactured item in 3D SolidWorks for the manufacturing process. They're doing structural calculations on the steel. They're doing all kinds of calculations on the material that we're transferring, how wide the conveyors we're using, how fast the conveyors need to be moving, All of the things that go into a project like this, they're going to help us on the backside. We've got 15 people just in our parts and service department alone, and we've got 5 individuals that do nothing but go out and do startup and training on these systems. We've done over 70 systems in residential single stream, commercial, MSW, and C&D type applications in the United States and Canada. Our sales offices in North Carolina are up in High Point. We were established in 2011 there at that office. We serve the entire United States, and you can't see that running along the bottom there, but we do have parts inventory out of our office in High Point as well. So we'll get into the system here, and just to familiarize yourself, hopefully this is relatively self-explanatory, but this is obviously the MRF. The OCC screen that you have currently is pretty much in the same position that we're showing it here. This primary ballistic for OMP, that is in the position of your current OMP screen, the disc screen. And then the secondary ballistic for mixed paper right here is in the position of what everyone knows here in this room as the beloved V screen. And so that's kind of from here to here is kind of what we're looking to replace. Now we've added a couple of pieces of equipment that we'll get into later, the optical sorters that we'll talk about, but that primary heart of your system is right there. So we'll start with the OCC screen. When we first got the RFP and kind of read through it and started familiarizing ourselves with it, a lot of times what you have to do is kind of read between the lines and figure out, okay, what is it exactly that they want to do? You guys did a really nice job putting together the RFP and taking some of those gray areas out for us, but we also had to think like a solid waste authority and say, how would we want to spend our money if that was our money too? So we took a look at the OCC screen, and one of the things about OCC, if anybody has kind of followed the market over the last 10 or 15 years, is that cardboard has gotten smaller. It's grown in the percentage of the overall whole, and it's gotten smaller in size. People in the industry refer to it as the Amazon effect. We've all heard about it. I know when I think back from about the middle of November until right before Christmas, what got delivered to my doorstep, and I'm only one person, we all know what getting those Amazon boxes is like and what it's done to the stream. And I'm sure if you walk to your MRF today and look, especially just before Christmas time, you saw a lot of that material. So as a company, again, because we are the ones that are manufacturing the piece of equipment, we're in control of the R&D of that piece of equipment, and we're in control of improving it. So we have worked to try to improve our OCC screen because, frankly, OCC screens went for many, many years without too many changes to them. We started seeing probably over the last 5 years, more than anything, a significant increase in the percentage of OCC, and like I said, smaller OCC. So one of the things that we did was we went to larger diameter shafts for reduced wrapping. So if you've been in a MRF and you've seen an OCC screen, I don't care if it's Christmas tree lights or Walmart bags or twine or rope or whatever, it tends to get wrapped around the OCC screen. The people have to go in there, they have to cut it off with razor blades or whatever the case may be, knives. They have to tie off, it's not safe. There's all kinds of issues that go along with it. And more importantly, it causes downtime in the facility. And that's the main thing, is if you're not running, you're not making money with that equipment. So what we're trying to do is maximize the amount of time that you're running the system. So what we've done in our new design is you can see here the size, the shape, or the size of the shafts is considerably larger. And so if you measure that all the way around, those are 10 by 10 shafts in there. So if you it's actually 8 by 8. So if you measure that all the way around, it's 32 inches. So anything shorter than 32 inches can't wrap around that shaft. And it has significantly improved the amount of wrapping that we see on the screen. The other thing that we've done is we've gone to tighter spacing, not only between the discs, but between the shafts. Because as you look down from the top of the screen looking down, if that opening size doesn't change in both directions, you don't get as much of the smaller cardboard. So we've changed the opening size in the left to right direction as well as in the length direction, and that's helped us to recover a lot of the smaller OCC. The screen that you had in there currently, or that you have in there currently, has larger spacing by considerable amount, and so a lot of the smaller brown materials end up on your fiber sorting lines. So what are the benefits? Because again, this is about, all right, great. Now, what are the benefits? Less downtime. If we can reduce the wrapping, then we will reduce the amount of time you need to get in there to clean it out. That is an increase in the amount of time that you're running the system. It's an increase in the tons that you are processing, an increase in the revenue that you are generating. Lower maintenance cost. My father told me for many, many years, there's only two ways that you can change your financial position. You can increase your income, or you can decrease your expenses. We're trying to do both. We're trying to increase the revenue that you're making by having less downtime, so you're processing more tons, and we're trying to decrease your cost, less maintenance, obviously more money in your pocket. As a result, the real numbers that we have seen from this screen over an existing OCC screen, not necessarily your OCC screen, but if we take one of our design OCC screens and compare it to the new generation, we're seeing anywhere from 15 to 30% additional recovery of browns just by changing out the screen. That's a significant number. You start multiplying that number by the cost per ton of OCC, the tons that you're running, the months that you're running, and by the years, that number starts to swell pretty quickly. So a 15 to 30% increase in the OCC that you're able to recover. Real quick video here, kind of showing the screen. I'm sure everybody's seen an OCC screen, so it's shouldn't be foreign to you, but much larger diameter shafts. You'll notice a little bit of wrapping here, but that screen right there has been running for about 4.5 hours in that facility, 4.5 to 5 hours in that facility when we were running it. There's the browns coming over the top of the screen. You can see it's a pretty clean material. These are the unders, and you'll see a little bit of brown in here dotted from time to time, but if you look at your stream now, it's got significantly more smaller OCC in it, which means that has to be picked off your fiber sort belts. So we're going to save you manpower in sorting that after the screen. If we can transfer 15 to 30% of that OCC from your fiber belts into your OCC pile, which is where you want it, which is where it should be, then it'll save you money cleaning the fiber up. The next step I want to talk about is the primary ballistic. I don't know how familiar you are with a ballistic separator, but that is something that it's an older technology. Ballistic separators have been around for 20, 25 years, used in mixed waste applications, even some C&D applications. It's been over in Europe for many years. We started putting it in applications about 6 years ago. We built our own. We've got over 70 units in the field today, 75, 78, something like that, in the industry today in single stream applications, not just ballistics out there, but ballistics in single stream applications. So applications in very similar to your kind of material composition. You've all seen this. This is a news screen or this screen with material wrapped around the shafts. And it's a problem. Not only, again, are we back to what I was just talking about on the OCC screen, but not only is the material wrapped around there, which means at some point you're going to have to get in there and clean it off, so it becomes a safety factor. But the other thing is that as the material builds up on the screen, those holes that I was talking about, those dimensions that I was talking about, start to close up. And that's not the way a screen is designed. You know, your grandma sifted flour in one of those old things, and if it gets clogged up, guess what? There's no flour coming out of it. You're just grinding the stuff up. So this doesn't work any different than the old flour sifter that your grandmother used. When you start to clog those holes up, it's not doing the job that it is designed to do. So we want to try to eliminate that as much as possible. So the ballistic separator Some of the design features, it has no exposed shafts for the material to wrap around. You can see how close together the slats are in this machine. And I'll show you a video of it in a minute, but just to give you the basic principle, if you're familiar with a walking floor, it's very similar to that, except in a much faster fashion. It's these paddles that are moving back and forth, and they are in effect bouncing the material. And the material bounces up the screen if it's flat, and if it's round, like a PET bottle or an aluminum can, it has a tendency to want to roll off the back of the screen. So there are no exposed shafts for the material to wrap around. There's also no rubber discs to replace. You can probably pull up a spreadsheet. I'm sure Mike could pull up a spreadsheet and show you how much money, Richie, you guys spend on rubber discs on an annual basis. It's a significant number. So we've eliminated rubber discs altogether here for you. Not only are you not having to pay for the rubber disc, but you're not having to pay for the labor to go in there and change those rubber discs when they need to be changed. Plus, you don't have the employee in the machine having to pull shafts and take discs out of there, and so because that's going to expose you to safety issues when they get inside the machine. The other thing is, because we use steel screening device, in this device here with rubber discs, we set the screen up day one to have a certain width between those discs. Let's say that width is 7 inches. Well, I start running material across it, and anybody in here knows that when you've got glass in the stream, it's going to wear and tear on the equipment. It starts to wear and tear on those rubber discs, and that 7-inch spacing becomes 7.5, then becomes 8, then becomes 9. Because the discs start getting smaller, so the spacing in between them gets bigger, so I start losing more material that I really don't want to lose between the discs. Especially, we'll talk about that a little bit more when we go on to the secondary type, because I know that was a concern that Rodney had in taking a look at the amount of material that you were losing to your fines and going to your glass. Good material in there that we want to try to recover. So what are the benefits of the ballistic separator to the Solid Waste Authority? First of all, again, we're back to downtime here. We try to target the highest mechanical availability possible. There are certain things that we cannot avoid. We cannot avoid people throwing chicken bones and deer heads and bicycles and Christmas tree lights in their recycling. It's going to cause your equipment to go down. We can try to mitigate some of that, certainly. And we do that with the equipment that we recommend. Lower maintenance cost. Again, we're trying to save you money on your maintenance because it is a big factor in the cost of running one of these facilities. And this safety risk. Safety is something that a lot of smaller companies don't necessarily pay attention to. When you start getting into the bigger companies, the Republics and the Waste Managements of the world who have their own divisions or departments that focus on safety, or a municipality or a solid waste authority, safety's important. You got to make sure that your employees are taken care of. So here's a brief video on the ballistic, just to kind of give you an idea how it works. This is obviously in slow motion. And it's just bouncing the material. And I know when you're looking at that, you may think, what in the world is going on that machine? But this is what, again, it's back to results. This is the fiber that's coming off the top of that screen, and you'll see very little contamination in it. And contamination could be an aluminum can or a PET bottle. We want paper where paper is supposed to be, and we want containers where container is supposed to be. And the ballistic does a really nice job of that. Here's another video. This actually is showing the second ballistic, but I can circle back with you on that. But this right here shows the container stream, and what I'm looking for there is I don't want to see any paper. I'm going to see some. I'm going to see a cereal box because it's three-dimensional, or I might see a shoe box or something like that, or I might see a small piece of paper because it went through the screens, but I don't want to see a lot of paper on that line. I want to send as many containers to the container stream line as I can, and I want to send as much paper to the paper lines as I can. So then we get to the secondary ballistic. So what we've got planned for you in your system is 2 ballistic separators. The first one is going to look more like the one on the left, and I'll explain that in a minute. The second one is going to look more like the machine on the right. If you look at the two, they kind of look similar, but the difference is that the one on the left has much larger holes in the paddles. The one on the right has these smaller 2-inch holes in the paddles. And the reason for that is because this machine is first in the system right after the OCC screen. I'm going to get my brown out, and I'm going to send the unders here. And then once I send the unders here, I want to get that fiber to be as clean as possible. And the way to do that is to allow material to drop through the paddles or allow material to roll off the back of the screen. And I want to get that material off the screen as quickly as possible, because the longer I allow it to stay on the screen, the more likelihood I have that it might bounce and carry over with the paper. Again, I'm trying to present as clean a paper as possible to your fiber lines. By having the larger holes, I'm going to end up with a better quality fiber going to your fiber lines. What falls through the holes here or roll off the back of the machine is going to go to this ballistic. Now I've gotten my containers out of my fiber, so I've got a really nice quality of fiber here, but I want to clean it up again because I still have some smaller paper that might have fallen through the screens here. Plus, I have capacity issues because these machines can only handle a certain capacity, and we went into this, the RFP asked us to be able to run 18 to 20 tons an hour. We need to be able to handle that, and we couldn't handle that with a single machine. So what we're doing is we're cleaning it, and then we're cleaning it again. What that's all about. Then we get into the optical sorter. Now this is a photograph, I don't know who went to Pratt Conyers, but this is the Pratt Conyers setup. You can see over here, do I have a pointer? Okay, gotcha, perfect. So this right here is my ballistic separator. You can see the angle on the ballistic here. That's kind of the angle of the paddles there. The material is bouncing around on the inside of the machine here. The two-dimensional fraction or flexible fraction is going to come off the top of the machine, whereas the three-dimensional fraction rolls back, or if it's smaller, falls through the screen. In this setup, which is exactly the way Brad has designed your system here, we are going to come off the top of this machine directly onto the speed belt. Now, to give you an idea, in a traditional system, your in-feed belt here might be running somewhere in the 150 to 200 feet per minute range. Your standard sort belts or transfer conveyors may be running in the 100 to 150 kind of feet a minute range, give or take. A speed belt could be running 600, 800, even 1,000 feet per minute, entering the optical sorter. You may ask yourself, okay, why do I do that? Well, the reason we do that is because when the material is falling onto that belt and it's traveling at a high rate of speed, it spreads the material out. So that as it enters the machine, basically are y'all familiar with an optical sorter a little bit? Okay, so in a nutshell, what it is it's a camera that's reading everything that's on the belt, a computer system that's telling the machine what it is, and then a series of compressed air nozzles that are isolating that object and saying, I want that object, and blowing a puff of air and sending it on to a separate conveyor. Well, if I don't have the material isolated on this belt, then my camera starts getting funky readings. The machine does not operate as efficiently. So I want to spread the material out. I want to isolate each individual item on the belt. I'm going to get more accurate camera readings, which means I'm going to get more accurate ejections out of the machine. So it's going to immediately hit the speed belt, go into the machine. What we're going to eject in this particular machine is we're going to eject out anything that's not paper, all contamination. So it could be an aluminum can, it could be a PET bottle, it could be a 3 through 7s bottle, it could be a shoe for that matter. If it's not paper, we're going to be ejecting on it. Not likely that a shoe is going to come over the top of a ballistic. I was just giving you an example here, but So what are the benefits to SWA? Significant increase in recovery of both PET and aluminum. Now, I know you may be thinking, okay, how is my PET and aluminum going up in a machine that I'm using to clean paper? Without the optic, right now in your MRF, what's coming off the V-screen as paper goes to a belt, and there are people standing there sorting through that material. Well, if you look at the burden depth of material on that belt and you look at the speed that that belt is traveling at, it's hard for a human to stand there and find every aluminum can and every PET bottle. As good as those guys are trained and as good a job as they do, they miss stuff. It's under another piece of paper, or it's under a plastic bag, or it's under something and they don't see it. We have seen a significant improvement in the recovery of PET and aluminum when you put it in an optical sorter, because it just frankly does a better job than a human can. Also, because that material is isolated and traveling at 1,000 feet per minute. How fast are your sort lines traveling on your mixed paper belt, roughly? 150. This thing is traveling at 1,000 feet per minute and going through a machine that's automated doing that job. Imagine cranking your belts up to 1,000 feet a minute and expecting your employees to grab a PET bottle. It's just not going to happen. So the machine can do it more effectively, can do it more efficiently, and it can do it a heck of a lot faster. So we've seen a significant increase there. That's something that often gets overlooked. Less contamination in the mixed paper. Less manpower. Then we go on to the next optical sorter. Actually, then we go on to the next optical sorter. This optical sorter, the first one is designed to clean up mixed paper. We're trying to get contamination out of the mixed paper. Now we've moved on to the container line. We've pretty much gotten your brown out with the OCC screen. We've gotten your paper out with your two ballistics, your best quality of paper, which is your OMP, and your second quality of paper, which is your mixed paper. Now we're at the container line. And the two items that are by far the most numerous and the most valuable on your container line are your ones and twos. Obviously, aluminum is another one. There's not quite as much of it, but we can handle that with a different machine called an eddy current, and you all probably know what that is. You've got one in your MRF. So we looked at a machine, and there's a couple of different ways you can handle PET and HDPE on a container line. You can buy two optical sorters, so you pass the material through one and it ejects all of the PET, and then you can buy a second optical sorter that is ejecting all of the HDPE. That's the way a lot of people do it. The problem with that is you got to buy two machines. We have a machine called a dual eject optical sorter. So we are ejecting two commodities in the same machine. We are ejecting PET upward and we are ejecting HDPE downward. Some may say, well, aren't two machines independently more efficient? And the answer to that is simply yes. But we're talking about minuscule percentage points in efficiency, 2 to 3 or 4% difference between two single eject optics versus a dual eject optic. The advantage to the dual eject optic is, number one, it takes up considerably less space. We went out there and, during the process with Rodney and Richie and looked and talked and where are we going to put this thing and where are we going to put this thing, and we looked for an hour out there at the facility one day because of the maintenance room that's in the back and all of that. Imagine trying to do that with two machines. It would have been difficult to do. So we're able to give you bigger bang for the buck. You sacrifice 1% or 2% in efficiency on the machine, but you gain the benefit of being able to handle two objects or two different commodities in one machine. So we're doing a dual eject PET and HDPE, which, if you know it by the numbers, it's the ones and twos. So what are the benefits to SWA? Improved recovery of PET and HDPE. There's less loss of valuable material or residue. Right now, whatever the sorters don't grab keeps on going down the line. If somebody on down the line happens to see it and throw it in a trash can or whatever, they recover that material, but if they don't, it goes off the end of the belt and goes to rejects. I'm sure these guys can give you good numbers on what your current residue looks like. And it's, what we're trying to do in this system is minimize the amount of residue. We know that you're gonna have some residue going out the back because you have residue coming in the front. What we don't wanna do is have good, valuable material going out to residue. Again, back to manpower. We come back to manpower, manpower, manpower. I have a machine doing a job, not a person, so you're paying for the machine instead of a salary. The benefit to the machine, of course, I'm sure you've all heard it, they don't call in sick. They work Saturdays and Sundays without complaining about it. They always show up. You don't have to pay them double time. And safe, again, it's back to safety. The other nice thing about the Optic is that it's got the ability to handle significantly more throughput without increasing the head count. Right now, on just your tons that you need to process, we're estimating somewhere in the 10 to 12 ton per hour range that you need just to handle the Horry County material or your own material. I know that the situation with Charleston, and that's changing and all of that, that may be going down, but the RFP requested 18 to 20, and it was just going to be impossible without adding 5, 6, 8 sorters on your line to be able to run 18 to 20 tons an hour without adding an optical sorter. So the optical sorter really saves a lot of people on the increased tonnage. So here's a short video that shows a dual eject optical sorter. The gentleman on the left is getting all of the PET. The gentleman on the right here is getting all of the HDPE. What he is doing is he is doing two jobs. He's QCing the material, so he's pulling anything out of it that's not HDPE. And then he's taking the natural HDPE and throwing it over onto a split belt. So he's doing a natural and a QC. The guy over here on the left is just doing a QC on the PET. So if it's not PET, he's picking it off the belt. So again, dual eject machine, one optic, PET, and HDPE. This guy can QC the material, and he can throw the natural HDPE, which has a different value to it, onto a separate part of the belt there.
Rusty, talk a little bit about the life of your optical sorters, and over a period of time, what has to be done to them, and what the cost may be to do that.
Okay. The life, it's hard to say because we started building we probably put our first machine out there about 7 years ago, still going strong. Industry-wide, as optics go, though, there are many optical sorters that have been out there for 12, even 15 years operating in plants. Typical things that go wrong with them are, bulbs, camera replacements, hard drives on the computer. We've got programs that you can get. You can get quarterly maintenance programs. You can get biannual, annual maintenance programs where we come in and do all the maintenance for you. As far as cost, it really depends on what happens to go wrong with the machine. It can be as low as $2,000 or $3,000. It could be upwards of $8,000 to $10,000 depending on what has gone wrong with the machine. I can tell you that I've probably sold 20 to 25 optical sorters in the time I've been at MachineX, and I've never had a customer with more than a $6,000 or $8,000 expense on their optical sorter in that period of time. And I've been with the company since 2011. So in that 7-year period of time, I can honestly say that I haven't had a customer have to spend more than $6,000, $8,000 on his optic.
Are there programming changes?
There are not programming changes, there are software updates, and right now we include those with our customers. We have not charged any extra for a software update to our customers. We have the ability to basically dial into the machine via Ethernet. So with the system that we have quoted for you, we have a standalone internet. So we're not using Charter Internet or Xfinity or whatever's around here, Spectrum. We are literally using a standalone internet that we provide. It's its own Wi-Fi. It runs the handhelds, but what makes it work is you're able to connect your Ethernet connection into it, so our guys can log in from Canada, get into your machine, and see what's going on while we're doing it. And I'll have to check, but I think we do software updates that way as well. I'll double check that for you, Bo. Let me get back to you on that if I may. I don't want to sound like Mark Zuckerberg and have to get back to you on everything, but that one question I don't happen to know off the top of my head. But yes, there are software updates, and so far we are not charging our customers for those.
On those ballistic
Yes, sir.
sorters, is there grease points for anything?
There are, and there's quite a few of them. They have to be greased every 40 hours of runtime. It's about a 45-minute job, 45-minute to 1 hour job to do it once a week if you're running a single shift. It's done from under the machine. We've been asked by other customers before if we would do some type of manifolded grease fitting to get to them, and some customers may do that on their own. The downside to those is we want people to get under the machine and do the manual grease there, because it causes them, just by virtue of being under the machine, it causes them to get under and inspect the machine properly. Whereas if you're doing it from up here and you're not getting under the machine and you're just greasing it from a central point, you may not recognize certain things that you would if you were under the machine. So we prefer customers to do those.
So you're saying that if we chose to put a manifold system or an automatic system on it, we could?
Absolutely. I mean, you can do, once you pay for it, you can absolutely do that. I'll check with our guys. It's not a warranty issue or anything like that. I wouldn't be too concerned about that. It's mainly just the fact of a serviceability of it, that we want you going down there and inspecting the unit. Inspecting the machine is part of the standard maintenance program anyway. So
I get that, but if you got all those guys standing around for 45 minutes waiting to get it serviced, you know what I mean?
it's not something that has to be done. It's like getting the oil changed on your car. They recommend it every 3,000 miles, but if you go 3,100, your car's not going to break down. So it's the type of thing that they can work into their schedule as they can. And if, for example, you stop running at 5 o'clock on a Friday afternoon, then you can just set it up to grease them at 6 o'clock, as an example. Kind of when you're not running the system. Does that make sense?
Yes, sir.
And certainly I'll be happy to take more questions when I'm
Can you
finished.
go back to the
Yes.
first screen?
Yes, sir. The very first one?
The very first one that shows the whole system.
Yeah, I have to click back through here, Mike. You can.
Okay.
How do you get it off?
What's the very first,
Rusty, how often were the grease points to be serviced?
every 40 hours?
Every 40 hours.
40 hours.
Yes, sir, every 40 hours, for the record.
When we went to Pratt, they had automatic greasers on your machine.
Absolutely. Not uncommon. It's not uncommon for people to do that. It is a maintenance preference issue. You can put a manifold on the machine if you want to simplify it. It is not a problem. Just be aware that if you're not under there inspecting the machine regularly, other problems could potentially present themselves that you don't find out about because you're not under there looking. Yes, sir.
The OCM screen?
OCC screen, yes.
Yeah, OCC. It's got all them blades looking on it. How often do they tangle up and looks like they would clog up, kinda.
Yeah, they don't. I mean, it's not to say that you're never going to have a jam. If somebody drops Christmas tree lights in there, for example, they can potentially get wrapped around that screen. I'm sure these gentlemen could probably do a better job answering that question than I could in terms of how frequent that happens. But as far as doing any particular damage to the screen, it doesn't. It'll shut the screen down, overload protections and that kind of thing, and you have to get in there and do the untangling. But it doesn't happen as often as you would think. And that's kind of the whole point to the new generation is we're trying to minimize the amount of wrapping that you do have. So all I can tell you is from a customer's experience, they would go from literally having to get in there at every break and lunch, and then at the end of the day, to just doing it one time at the end of the day. So one customer, for example, I can think of a couple right off the top of my head, American Disposal up in Manassas, Virginia, and then Rumpke in Cincinnati, and I don't know that we've done Columbus yet, but I know we've done Cincinnati. They went from getting in their screens 4 or 5 times a day to cut the wrapping off of it to doing it once a day. So it saved them significant downtime. How often do you have to get in your screens?
We get in them at the end of each shift,
Okay, end of each shift, yep.
but we have to do it on all 3 screens, the OCC screen, the ONP screen, and then we have to, on the B screen, we have to do an extra cleaning on it. Usually takes about 8 hours on Saturday.
Yeah, wow.
Before
Yeah,
you-
and that's the other thing, cleaning.
Let me just say one thing before you go on.
Yes, sir.
I think we need to, as board members, remember what we're looking for is, we're looking at the kind of equipment, and we're trying to see how much more efficient it's gonna be than what we already have. I mean, it's common knowledge that we're gonna have to have some maintenance.
Yes,
And
sir.
anything's gonna have to have some maintenance, gonna have some downtime. It is not going to, I don't think we're gonna be able to find, maybe I'm wrong, but I don't think we're gonna be able to find something that's gonna be infallible, that's gonna screen out everything and don't have some maintenance, don't have some downtime. And at the end of the presentation, I will let you know what I'm taxing Mike to do by looking at all of this equipment. But what I wanted you guys was to see the different kinds of equipment and the process in which it would be operated. But go ahead, I don't want to get too technical into a lot of the technical questions that these guys should be able to answer when they look at the RFQ. That's just, okay.
Well
I'm
said,
sorry.
thank you for saying
Go
that,
ahead.
that's well said, yep. So, let me go, and that's not to say that I won't take questions when I'm done here. I'm just maybe a few minutes away from being done, I'm getting close, but I'm happy to
Okay.
take any questions. So really, we're kind of down to the last slide here. I'd like to summarize the benefits to the Solid Waste Authority. And those are improved recovery of your OCC. OCC is one of the products in your MRF that is profitable. It's got a good price value to it. It's fluctuated between probably $75 to $200 and maybe even as much as $250 a ton over the last few years. But it's been a good positive for a lot of people. So if we can improve the recovery of your OCC, we know we're going to help you on the revenue side. Improved recovery of mixed paper. Let's not confuse that with OMP. Let's specifically talk about mixed paper. Right now, you have a lot of mixed paper that is being lost to your residue. We are going to recover that mixed paper, not only because we're putting in different screening devices, and the secondary ballistic separator is going to do a better job of recovering that smaller mixed paper than your V-screen currently, but also because of the fact that we are putting in the optical sorter to clean that material up, we're going to see a higher percentage of mixed paper on your mixed paper belts and less of it going out to residue. We're going to improve the recovery of aluminum and PET that's currently going in your mixed paper bales. If you will go to your mixed paper bales and break them open and do a count, there's PET and aluminum in there. I'm not saying we're going to get it to zero. I think Mike said it perfectly, that nothing is infallible, nothing is perfect. We are just going to improve that recovery percentage, is what we're going to do. We're going to improve the recovery of PET and HDPE because we're putting in the optical sorter, and frankly, it's going to be able to do a better job than putting 2 or 3 people up there on the line can do. We're going to have reduced system residual, and again, I want to be clear there. We cannot take trash on the inbound side and turn it into gold on the outbound side. What we're trying to do is take in the gold and get the gold out of the stream and not send that gold to the pile of poop out there in the compactor. We're going to significantly improve your uptime. We've got several customers well in excess of 90, 92, 93% system availability, mechanical availability. If we can improve your uptime, not only are we saving you money on the maintenance side, but we're increasing you on the revenue side because you're actually running the system. Less parts and maintenance costs. Eliminating rubber discs alone is going to be a significant savings to the Solid Waste Authority. Cleaning the screens is going to be a significant savings to the Solid Waste Authority. And less manpower. Less manpower, yes, sir.
Have you quantified the staff reduction that we would see?
Yes, sir. We have, and that's my last section
Sorry
here.
to jump.
Mike's got the hard numbers. I'm giving you the 30,000-foot view numbers. So the headcount impact. Good question, Bo. So when running the system at the required tonnage of the Solid Waste Authority, which is about 10 to 12 tons per hour, we are estimating a reduction of somewhere between 5 and 11 people out of your current count, which is 26. So we're saying somewhere between 15 and 19, I think 15 and 21, I'm sorry, 15 and 21 total to run that, and you're doing it currently with 26. On the flip side, the other way to look at that is, can we run more tons with our current head count? And the answer to that is yes. By staying roughly in the 26 range, I think we're recommending 27. So roughly in the same head count, we're able to virtually double the system capacity to 18 to 20 tons per hour without increasing your head count. So with that said, I will be happy to open up the floor to any other questions, any questions that you may have. Yes, sir. And if they're technical, I can go ahead and tell you right now, I'm going to defer to Brad, so.
Can you touch upon?
I never get out of my lane. You've heard that phrase, get out, stay in your lane. I'm going to stay in my lane, I promise.
Okay, Bo.
We used this RFQ, we stood up an RFP because we wanted you to tell us how we should replace our equipment.
Yes, sir.
But we gave you 3 variables that you could not change. We chose the timing, we chose the budget, and we've got a single stream system. Of those 3 elements, is there anything out there that's on the horizon? And as far as what's technology that's on the horizon, if we were asking you to do this a year from now, would you change your proposal? And are we too short on our budget? If we increased it by 20%, will we see a different proposal from it?
Those are really good questions. The first one is a bit of a crystal ball question. I can tell you that there's nothing that I'm aware of that we are currently working on in our R&D that is going to significantly impact system design. I can say that we are looking at all of these items in our R&D to improve them. We are constantly looking to improve our OCC screen. We are constantly looking to improve our ballistic separator. We are constantly looking to improve our optical sorter. But is there a magic wand out there that we see on the horizon? The one thing I see that is a big, big problem that needs to be solved is plastic bags. We've all tried to come up with a magic box that you can put, 1 million Walmart bags in it and it comes out in a pellet or something. I mean, there's no real easy way to deal with plastic bags, film plastic in a MRF. It's very difficult. What we can do, again, is try to mitigate the damage that those plastic bags cause, and we've done so by utilizing the ballistic separator.
Mike, Bo, let me address that for as technology concerned. When I was in Cherokee, there were a lot of presentations on new technology, anywhere from robots to robot arms to optical sorters, all of these things. The ideal that they came up with is not an exact science. There's not a lot of companies that are out there building these new things because of cost. And what they see as a near future is anywhere from 5 to 10 years before there would be something that they would consider to be a true technology kind of things. And the one thing that they did mention about the robot arms, we're talking about maintenance and cost. It's very expensive, number one, to install, and number two, it's very costly to maintain. And you don't get the precision as you get off of some of these other optical sorters. So that kind of addresses some of the technology. I see where we're going, that we don't want to put anything in place that we may do within the next year, but I don't see that in the cards based on most companies that are out there.
But our RFQ
Yeah,
doesn't
right.
accept those given.
Right.
I want to know if there's anything outside the box that he would have
Right,
modified.
and
our
there are things outside of the box, but those things outside the box come with a cost. And I don't know if it would be a best fit for the Solid Waste Authority here.
Yeah, that's right, and those are, again, excellent points. We, just to let everybody know here, we build our own robot. It's called the Samurai. You can see it on our website, you can see it in YouTube videos. We've got one installed up in Lakeshore in Chicago. It's doing a really nice job. We didn't even bring it to the table in this particular application, just because of costs, just because of, frankly, the like he said, the cost of maintaining, the cost of installation, the cost of maintenance, and the current efficiency that they're able to operate at, the numbers don't make sense. So we decided not to even present it here. But your second question is, if we had 20% additional budget, would we have proposed anything differently? Always. If you've got more money to spend, we're going to try to put in more equipment. I mean,
Spend up to it.
absolutely. You give us more money, I can tell you, we're going to try to
Come
spend
up
it
with
for you.
something, yeah.
What you want? Richie, I think, had a question.
It's no secret we have electrical issues. We call it the ghost. So can you explain how you're going to integrate your system into our system electrically? What is all going to transpire with that?
You want to answer that? You want me to take it? I mean, all right. That one is, I'm glad you asked me that question, but we are not basically reusing anything out of your existing system except for the Baylor controls. Those are kind of standalone anyway. The rest of the system, from the in-feed conveyor all the way through to the residue conveyor. So basically, your in-feed, your pre-sort, your OCC screen, your fiber sorting belts, your container line, your eddy current, your residue belt, every conveyor, your bunker doors, your bunker doors are part of the baling, but the rest of that is going to be replaced with all brand new. We're going to come in, we're going to rip every wire, piece of conduit, controls out of there. We're not going to have this communication software trying to communicate with that communication software. We're going to try to eliminate the ghost. We're going to try to get the ghost out of your facility by supplying you with all brand new controls, with one control brain, if you will. Yeah, and everything up to date code wise. There, over the years, codes change. I'm sure when you put the system in, you were up to code. Some of those codes may have changed. Well, now we're going to make sure that everything is up to code from a safety standpoint. Absolutely. NEC codes and NFPA and all of that.
Have you analyzed the power consumption change?
We have not. It's not significant, though. We know it's not significant. I mean, the compressors are probably going to be the biggest addition to it.
There'll be some additional drops for the optical sorters, but I think the main panel is fed with 400 amp currently. Depending on the options and everything that you guys decide to go with, we may be able to keep that 400.
Okay, any other questions we got? All right, I appreciate it.
Thank
Thanks
you.
a lot.
Yeah, thank you very much.
All right, we'll take a break until our next guest arrives.
Van Dyke Equipment Company, Recycling Solutions. They have a nice corporate office. We went to go see it in Connecticut. So they have an extremely nice corporate office with a nice wall that's got plants from the top floor to the bottom floor. Real nice. This is Mark. He's their director of sales, and Jeff, he's the one we've worked with the most. We call him Jeff, so, but he's the sales manager. He's out of North Carolina.
Yes, sir.
And Mark's out of Texas. Y'all see on their business card. We're going to turn it over to y'all, and these gentlemen's one of the 3 companies that gave us proposals for a new system. All right?
Well, thank you, guys. Thank you, ladies and gentlemen. We appreciate the opportunity to come here and present what we've already offered out in the proposal and some of the responses to the RFP you guys have provided. We're looking forward to moving in down the line with you guys in the project, hopefully, if we're successful. I want to start out with just a few slides, giving you a little bit of background, since I'm assuming most of you guys are not familiar with the companies that have bid. So it'll be brief, just 3-4 slides, introducing who we are, give you kind of an idea of where we are in the industry, a little bit of our history, size, scope, and our competencies. So we are the largest supplier of MRFs throughout North America, and that's not even by a close margin. We're probably double the size of the next competitor. We started in 1984. We're owned by 2 brothers who came over here from the Netherlands. They now both reside here, and the second generation has started in the company, so our succession plan is in place. We're headquartered up in Norwalk, Connecticut. Mike referred to our wall that we have. We call it a living wall, and it's all greenery. We took 5 years to build that facility, and we're moving from Stamford to Norwalk, and we're actually just in the process of doing that move now. It's roughly 280,000 square feet, and it's where we house most of our parts and where we do training schools for a lot of our customers. We've got equipment operating in just over 250 facilities here in North America. Averages are a little up in the air. Nobody can really nail it down exactly, but best estimates are there are a little over 400 MRFs operating in the U.S., and we're in about 250 of them in some shape or form. We've provided the largest recycling facility in the United States that's operating all of our equipment in Brooklyn, New York. And we've had about 1,700 successful projects that we've started since 1984 when we were established. Some of the higher profile facilities that we've done is that New York City's facility that we talked about, that I just mentioned. This entire state of Rhode Island, even though it's not a very big state, 100% of the recyclables that are processed in Rhode Island are processed at one facility that we've provided the equipment for. It was part of the tour that some of you guys all went to. The City of Toronto, 100% of the City of Toronto's material is also processed on our equipment. The City of Dallas, about a year and a half, 2 years, we were awarded the project, and it's been up and running since then. The City of Houston, we were awarded as well. We are about to start running material there probably within the next month or so. And then City Fibers was the first single-stream MRF on the West Coast, which is probably some people may argue that there might have been one somewhere else in a smaller format, but it's usually recognized as the first automated single-stream MRF in the United States, and we were the ones who provided that. Homewood being the first single-stream facility in the Midwest, we were also a part of that. One of the reasons why we are so big is Waste Management, who's the largest processor of recyclables in the U.S. About 70% of all of their facilities are ours. We do about 14 million tons, or I should say, they process about 14 million tons annually over our equipment. And like I had mentioned, we got more installations than just about anybody else in the country. Give you an idea, just that's our map where all of our facilities are sort of located where we've had equipment. Our service, we have about 32 U.S.-based technicians. We say about because it runs between about 32 and 35. As you may imagine, being on the road as a technician, it's kind of a hard life. So we usually have 2 or 3 people that are transitioning in or transitioning out as they start moving in off the road. Yeah. And that's kind of where they're physically located in the U.S. Relative to where you guys are, or we are today.
So the 2 white dots that are closest to where you are.
Sorry. As far as going back again, what we do, we believe that everything we sell, we have to service and support. We've got equipment 30 years out in the field that we still have parts and technicians trained on to go out, fix, and support with both physical service as well as spare parts and wear parts. We carry about $16.5, $17 million of inventory on site. Some of the folks here who went on the tour got to see some of the inventory that we've got. I wouldn't guess what the multiple is that is above what all of our competitors are carrying. We have automated our ordering and parts to kind of facilitate. Again, we know that when we supply equipment, it's got to be supported. It has to run, it has to operate, and part of that is being maintained. And the maintenance can only do so much if they don't have access to parts, they don't have access to skilled technicians to talk them through things. It doesn't matter what the maintenance abilities are. They need to be supported by the manufacturer. So we do that With that inventory of parts, we've made the ordering of parts through maintenance a lot easier. We have an Amazon-style website where you can point and click. You can see pictures and parts, your system diagrams. We went through that again with some of the team that did the tour as well. Our order fill rate, now, even though we carry almost $17 million in parts, it's almost impossible to have a 100% fill rate because we don't carry 15 of everything. Some we have limited numbers on. Our fill rate is about 99.5%, and we track that on a quarterly basis. Our technical support is free. We do not charge for it, and it's 24/7, 365. If you call our service number, you get a technician on the phone who walks you through whatever the questions or problems that might be presented. If they can't be solved over the phone, we can set a date and schedule a physical service visit right then and there on that call. Also in our facility, we have a refurbishment shop where we do balers and we bring back some equipment and we'll refurbish it a little bit. And then, like I said, we do a lot of the training. So we have Van Dyke University we've branded. We do baler schools, optical sorting schools. Some of the higher technology components that we sell, we'll invite customers in. It's usually a 3 to 4 day class, very small, no more than 7, 8 participants. It's a lot of hands-on teaching and coaching, and it kind of allows our customers' maintenance departments to increase their uptime and just be a little bit more self-sufficient and build confidence in the operation. Again, that's where everyone's located. The black dots are sales and service, and the white dots are strictly service. So that's enough of the propaganda about our company. I want to talk most of the time about the project that we've got in front of us now to upgrade the facility down the street. Our understanding of the project goals were you currently are running around 10 to 12 tons an hour is what you're averaging. We were just over there a few minutes ago, and you're running a little harder now, probably closer to 14 and 15. But the average is probably 10 to 12 from what we understand. It's a very manually intensive process right now. It probably was fairly automated when you put the system in a decade ago. But as of current standards, would be considered a relatively manually intensive operation right now. You're running about 14, 15 tons an hour, and you're doing it with 27 sorters. To give you a little bit, we'll go into it a little bit further. We're looking at a system that would upgrade you to about 20 tons an hour and run with about 12 to 15 is the range of sorters we would expect you guys to run in and still maintain the same quality. Currently, it's undeniable the quality of the fiber you guys make is unmatched. You make a great quality fiber. The recovery of the available recyclables, I would consider, so that's an area where we can still improve on from the current operation. Future, we want to basically double your throughput. You're going at 10 to 12, and we're thinking 18 to 20 is the target range for where you guys really need to be for what we understand your projected and future growth. We definitely think the reduction in labor is mandatory. If you're running 27 sorters to do 10 to 12 tons an hour, not only would it be hard to just staff the additional people that you'd need to run that throughput, you physically don't have the space up on the catwalks or in front of the conveyors for them to actually work. You physically couldn't put them up there. So, automating and getting rid of some of the labor is an absolute must just to survive at these throughputs. We know you have to maintain your fiber quality. It's non-negotiable from what we understand. And we want to increase the recovery. That's kind of what we're looking at as primary goals. On the side here, just so you get it, we took the information you provided off of the RFP, and that's roughly what the composition is by percentage. And it might be a little bit off. If you guys were to do a floor audit, I think you'd understand very quickly from looking at a floor audit versus auditing the shipping of actual commodities. You'd find that you probably are losing quite a bit of ONP, quite a bit of PET, and quite a bit of HDPE that are just going out in residue simply because it's not being recovered. So these numbers are actually a little artificially low, and that speaks to a double hit on revenue because you're increasing your expenses going to the landfill, which I know it's still your own, but you have life cycle aspects of that as well. But you're also losing just revenue. You're putting valuable commodities into the dirt, which is something that we're adamantly opposed to. So our focus was obviously to increase the throughput because we know you need to grow. Absolutely reduce the labor ratios. We talk about labor ratios all the way is in sorters per ton. It's kind of one of the ratios that we kind of keenly focus on. Currently, right now, you're about a half a ton, should be about 0.5 to a 0.6 tons per sorter processed. And we're looking to take you guys up to, 1.4, 1.3 tons tons processed. To give you an example of that, each sorter over a 10-year life cycle of a system that we can reduce is about $335,000 or $330,000 back into the SWA that they don't have to spend. So just a reduction of one sorter is a little over $300,000 on a 10-year basis. And when you go into throughput, 1 ton of additional throughput that you need to run also works out to about $330,000, $320,000 annually in operating costs, simply because you have to run and you got to run additional hours, and it usually runs into the overtime situation. Maintenance cost, we wanted to really focus on the design to make sure everything was accessible and the components we were putting in were easy to maintain and had a low cost of maintenance as well. The recovery revenue model we talked about, we know we need to put more efficient devices in your current system to increase that revenue and increase that recovery points. We also understand that the only constant in this, when you're running a MRF and you're in the recycling business, the only constant there possibly is that every single day something different comes on the floor. The volume changes every month, every week, from year to year. They had that mass balance that we had before on the previous slide. If you go year over year over year, those numbers change dramatically. The news content has probably been cut by 1/3 in the last 10 years. PET numbers have tripled in the last 5 years. So there's always a balancing act, and whatever we build today has to be flexible for what's going to be done in 5 years from now or 7 years from now. So we have to build some flexibility into that as well. So the proposed solutions, so we came to go after that, we're looking at 2 main areas of the system. One, the screening package that you guys have down the front of the system. The fiber separation in the screening absolutely has to be replaced. 2 reasons. One, the technology is a little bit out of touch with where we are 10 years later, which is to be expected. But also, from a throughput standpoint, there's no way you could get any more capacity down that line. The second is the container recovery. On the back end of the system, the container line, if you were to double the throughput, right now you've got 6 people up on that container line. They're all working 2 feet away from each other. If you double the throughput to maintain the same recovery you're getting right now, which is average at best, you have to put 12 people. Would give them less than a half a foot between each other. They couldn't physically be up there on the line. So we've looked at completely reconfiguring the container line to allow for more labor to work more efficiently and to reduce the burden depth and account for the double throughput that's going to be up there. It wasn't just adding technology or adding some automation for the recovery. We had to completely reconfigure the line in our proposal. So again, complete overhaul of the primary fiber, the addition of the fiber separation, automation on the container line, automation on the fiber QC, and then rearrangement of the container line is really the key points that we've done in the design.
Jeff's going to get the 3D model up now to kind of show you what the design looks like. So everything you see in red is your existing infrastructure as the plant is now. Obviously, it's not red in color now, but it just gives you a feel for what is existing versus what will be added.
So I don't want to get you guys too dizzy walking around this thing, but you can see, if we zoom in here, right now, your entire container line is set up on this side of the fiber bunkers. We've added automation where we're taking out ferrous from the magnet, adding an optical unit to take out PET, which is the highest per piece item of the container stream, and then aluminum underneath. So that way, steel, aluminum, and PET are all out of the screen before any manual sorters see anything. That way, on the back end here, you've got roughly the same amount of space, but instead of picking pretty much every commodity up front, your sorters now only have to focus on HDPE, and that's pretty much it. And the only other thing they'll be doing is catching the stray piece of plastic or aluminum or ferrous that wasn't caught by the automation. So not only will they have less of a job description to go after, they'll actually be able to be a second chance or a last chance to recover any commodities that may have been missed with automation. Because while automation is significantly better, it's never at 100%.
And we saw today, you're doing a little bit of last chance recovery now under your line on the residue line. What Jeff is showing you, your last chance line will actually happen real time and be able to put right into the bunker that it belongs to. So it's really one-touch handling. So one-touch handling of number 1 plastics PET and number 2 plastics HDPE after the automation of the container line.
So this is actually the residue line currently running. Now, as you can see, as the volume has changed, the system has become slightly outdated just because of the volumes that have come through, as well as the evolving ton that we like to use, or the changing of the material composition. There's still a lot of recyclables that can go in there. And that just takes burden off the landfill and adds revenue to the overall operation. And nobody really likes to look at that, but that's actually the reality in most facilities. It's not unique to Horry County. So one of the main things we're looking at doing is obviously replacing the O&P screen that we've got in there now. The current O&P screen that you have is a little narrow, and what we've done is we have updated it with a newer style screen. It's a little bit more wider, a little more efficient. The biggest aspects of that screen are that it is now designed where the labor to clean it is significantly reduced, if not almost eliminated. What we do, but the biggest problem that we have with O&P screens of the vintage and style that are out in the market for the most place, we get a lot of wrapping of material, especially film plastics and things like that. And if you go see the MRF, we've got pictures of it. The screen gets wrapped up. And when the screen gets wrapped up, the openings get smaller and smaller and smaller, and the screen becomes a conveyor and stops actually screening. So while the screen produces good quality for the first maybe 30 minutes to an hour and a half to 2 hours of the operation, as it gets further and further into the shift and it gets more and more clogged, the performance of the screen dramatically drops, which means recovery goes down, quality goes down, and when quality and recovery go down, you have to add labor to it. It's one of the reasons why you guys are running a pretty labor-intensive operation. So what we've done is we've designed a screen that basically wraps, we don't say doesn't wrap, but wraps a whole lot less than anything that resembles what you guys have now. That's currently that isn't your screen, but I can tell you that is almost an identical screen to what you guys have.
I would add that Walmart bags are the biggest culprit in problems at every MRF in the United States, and Horry County's no exception to that. So this is, if you look closely, this is just a picture of grocery store, Walmart, and Target bags that wrap into a screen 30 minutes into the run. And I bet if you ask your ops people, we were just visiting with Kenny a minute ago, I bet several minutes to hours are spent every day cleaning this screen.
I think you guys are about an hour and a half per shift. Is that about right, Richie? About an hour per shift. Well, the other thing, too, is if you go back to one picture, the way you clean a screen is archaic and dangerous. I mean, if you've ever seen it, it's frightening to anybody who's not in the industry. These guys are generally walking around on a round shaft that actually rocks a little bit on top of slippery material, and they're cutting it off with a blade. I don't know what you guys particularly issue to your folks. Most of these guys have homemade blades that they sort of have figured out, and they look like medieval weapons for the most part. But the idea of these guys walking around on that environment, and that's just not something you want to do to your employees. If you can avoid that, you just want to treat them a little bit better and provide them a better working condition. Right now, there is no other option, though. So if you look right here, we look at an hour and a half, maybe you guys are at an hour. But if you go to 20 tons an hour, all of a sudden now we're probably looking at doubling that time. We got feedback since we put these new screens in the market. Shifts that run 30, 35 tons an hour spend 15 minutes. Usually at the end to inspect the screen, make sure there's no damage to any of the rubber stars, and clean out a little bit of stray material that might be in there. It's much safer. And the biggest thing besides the safety is that the screen performs at the last 20 minutes of the shift the same way it did at the first 20 minutes of the shift, which allows you to get more consistent, throughput and quality that everybody's going after, which allows us to run less labor on the fiber post-sort lines or the QC lines.
Here's how they do it.
So the inside diameter, you can see we've stuffed the bag. It's really simple math. It's just that if you build a shaft that's not wide enough, and the diameter is such that you can't, the circumference, I should say, isn't such that the bag can wrap, it doesn't. Now, 90% of what wraps is grocery store bags like this. You know, when we get Christmas lights and things like that, you still may have, or ribbon, you may have a stray wrapping, but it's so dramatically reduced. Here's 6 hours after running in Dallas. That's 60 hours of running time in San Francisco. So while we do say it's, you know, it doesn't wrap, you can see it's virtually no wrapping, but there's still a very, very small amount. But going in there is significantly better than the alternative of going in the other screens. After the fiber, we looked at the number of guys you have and girls you have in the post-sort QC rooms. Currently, you're running about 14 people to QC your fiber. It's kind of a high number. So what we've looked at doing is we've added some pre-quality control using an automated optical sorter. So what we're going to do is we're going to take the lion's share of the contamination out before we actually see the people using an optical sorter. And I don't know what your familiarity is. We're third, so we're assuming that you've already seen some operations of optical sorters prior to us being here. But essentially, we're using near-infrared wavelengths that we're getting the feedback from, as well as spectral and metal detection. We're looking at that through visible light and obviously the metal detection, and then using air to target specific areas of the belt that we've identified a contaminant. There's a quick video. Again, if you guys are very familiar with it, let me know and we'll just pause it out. Otherwise, it should take maybe a minute and we'll just give you a little animation of how it actually works. So it's a relatively compact unit, pretty self-sufficient, very low in maintenance. The yellow line represents the light signal that's hitting the belt. Some of the things that are a little specific to what we do in optical sorting that are slightly different from others that are out there is that our light source and reading technology that we're actually getting the feedback from is roughly 5 feet off of the conveyor belt. MRFs are relatively a dirty environment, a lot of dust, a lot of grime. Every optical sorter out there working on fiber or containers works fairly well, again, for the beginning aspects of the operation. But after 30, 40, 50 minutes, an hour, hour and a half, as dust and grime and grit and everything else, think of it like the light source is like a windshield. When you're driving around a long, long time, it gets dirtier and dirtier and dirtier, and it gets harder and harder to see. Optical sorters are just after optics. They can't see, they don't perform. So by being 5 feet off the belt, where most other companies are about 1.5 feet off the belt, the lenses stay cleaner, the light sources stay more pure, and the performance is consistent and constant throughout the entire shift. The reason why we're able to be 5 feet off of the belt is that the resolution that we're utilizing is significantly more. Standard in the industry would be basically the first, and maybe the second best competitor might be in the second point. Our standard is in the third, and you can kind of see the resolution points. Our resolution is the same resolution technology that we're utilizing in flake sorters, where you send your PET and other plastics, they grind it into flake, and they run it through a flake sorter, which is identifying objects that are maybe 1/4 inch to a 1/2 inch big, if not smaller, and their purity levels aren't measured in percentages, they're measured in parts per million. Usually in that 50 to 70 parts per million is an acceptable rate. So the technology that we have for identification and resolution is piggybacked off of that. We realized that with that kind of resolution, we can move the units way off the belt. And about 4 years ago, we decided that that was a good idea. And since then, we've had a lot of customers, actually with no reason whatsoever, because they've got the same performance they've always had on their old units, have been doing wholesale changes to the AS4 models, which is what we're looking at here. Sorry, go ahead.
You go the whole shift without having to clean the lens, and that's a huge difference in the industry compared to what others are doing. We're at 5 foot off the belt, everyone else is at 1.5 feet off the belt. So just like Jeff was talking about with the screen, you only have to clean it once a day. in essence, the lens only has to be cleaned once a day. So you maintain peak performance throughout the run.
And we say once a day as the manufacturer's recommended line to clean the lens. If you guys remember speaking with some of the folks that you guys were on the tour with, those guys do it like once a week. Is kind of where they're averaging. You have a V-screen, which I was very excited to see, because in the U.S., I believe it's one of 2 left. Could be a third out there I'm not aware of, but I believe you got 2. Now, when you bought it, it was the peak of technology. I mean, there were a couple of dozen of them floating around. So we've decided we think the V-screen needs to get replaced for a couple of reasons. One is the V-screen is incredibly expensive to maintain because of the star count. There are so many stars in that thing, and it wears so fast that you only have the expense of all those stars, you have the labor expense and time to go in there and change them all out. And if you think going in that one angled screen is difficult to clean like we saw, going in a V-screen where you've got multiple things going on, it's even more complicated and dangerous. So getting your guys out of the screens, eliminating the star replacement cost, the other thing too is, like a screen wears. As it wears, the openings, the target size changes. With an elliptical, the target size is always the same. It doesn't wear. It's consistent, and you get the same throughput, same product quality, the first hour as well as the last hour. It also provides 3 separations, kind of like your V-screen. You get 2-dimensional over the top, 3-dimensional off the back, and whatever target size you want going through. It's a small little video. It's mostly animation. It'll kind of show you how it works. Some people refer to this as a ballistic in the industry. We call it an elliptical. We felt like elliptical probably resonated better with most people because it sort of is like the elliptical machine at a fitness center.
So this is a huge development really in our industry to have a ballistic separator or an elliptic separator. I know others are offering it. We're big believers in it, but we're big believers in it as the final screen in a system, not as the primary screen in a system, because it still is limited to throughput when you have more fiber, 2-dimensional fiber and film, versus bottles and cans. So there's a good mix. So replacing the V-screen with this elliptical is the perfect match. So in combination with a non-wrapping screen, we think we have the best of both worlds there.
We had mentioned this in our first presentation where it was a much smaller crowd. Van Dyke Recycling has pretty much every screening or separation technology under our roof. Whether it be optics, magnets, eddy currents, rotating shaft screens, elliptical screens, vibratory screens, trommels, whatever's out there, we pretty much have in-house. And we're able to pick and choose the technology that we think is best suited for the project. It's not that, if all you have is a hammer, every problem's a nail. We literally have a full toolbox. So we look at the problem and then pick the right tools for the problem. We think, again, the elliptical does a great job when you have a majority of 3-dimensional material and a minority of 2-dimensional material. When you have a majority of 2-dimensional material and a minority of 3-dimensional material, the rotating shaft screen works a lot better. So we feel like they both got a place, and we think they both have specific places in the system where they work well. After that, we've gone to the container line where I've talked about rearranging, but the PET recovery has to be automated, especially at the volumes you're talking about. So at 20 tons per hour and roughly 3% PET, I think your stated numbers were about 2.5. But I think once you realize how much PET is currently in the system, it's only growing. We're seeing numbers in excess of 5 at some facilities. It is going to continue to increase. But just at 3% plus or minus, that's about 20 pounds per minute coming across the line. Which doesn't sound like a whole lot, except for when you come to realize that it's 40 pieces. It's probably on the lower end. Some estimate it's 50. But let's say on the lower end, it's 40 pieces per pound. Well, it's 800 pieces. Physically can't, think about the average sorter who's doing a great job is doing 60 picks per minute. And I think if all your sorters are doing 60 picks a minute, Rodney would have had a great Christmas. Bottom line is most sorters don't do 60 picks a minute. And if you're just thinking about 60, how many sorters would you just need to recover PET, which is arguably the second most valuable commodity, if not the, well, depending on where HDPE floats, it's usually the second or third most valuable commodity in the shop. So the sheer numbers necessitate having automation there. So we feel like by automating, not only are we reducing the labor count, but we're also going to be increasing the recovery and dramatically increasing the revenues as well. So rerouting the container line, why we're doing that. Again, we want to get as much of the burden depth off of the belt before the manual sorters are coming into play. By reducing the burden depth on the belt, you can't see what you can't pick. So the idea is by thinning out the amount of material, the sorters who want to do a good job are allowed to do a better job because you're presenting material in a way that they can be more effective. So we're taking out all the aluminum, we're taking out all the metal, and we're taking out all the PET prior to any sorters. And what we're able to do, we basically took the same footprint and we just really mirrored the layout, so we put the automation in front as opposed to afterwards. The second aspect of that is that currently you have to come off of the line onto the floor, which is what every MRF wants to try and avoid. So we have our sorters come down and then having to go to the floor to get up to a set of stairs to go back up to the container line. By rearranging the container line, the manual sort platform where the sorters are going to be for the container line basically attaches now to the main fiber post-sort platform. So essentially all your sorters are now connected. Makes it a lot easier to manage them, but also makes it a lot safer environment because you can keep your eyes on all your employees. And it also allows them to have one point of egress and exit onto the system and off the system. So it just allows for the operation to be a little bit better controlled. One of the things that Mike had asked me to make sure I presented and put into our talk today was the staffing requirements. And I think I talked just a little bit about it early on. The staffing requirements, I kind of tried to explain what and why. On the pre-sort, I still think you're looking at 4 people on the pre-sort. On the OCC, we put 0 to 1. We are changing out the OCC screen as well. It really, the OCC screens that you guys currently have utilize metal stars. Spacing is very difficult to control. If you wanted to change the spacing on your OCC screen, you actually have to weld or cut off stars and then re-weld them back on. It's kind of labor intensive and you gotta be pretty sure what you want to do. The OCC screen we're looking and offering here is a combination of some metal stars in the beginning to help break and promote glass and moving material forward. But after that, it transitions to a rubber star. It allows the material to be moved a little bit more efficiently because we've got a higher coefficient of friction. But on top of that, since they're rubber, they're put on and bolted on with spacers as well. So for us to change the opening and target size, you're not welding and cutting, we're unbolting and rebolting. So we can change the size and be a little bit more target effective. By doing that, you may be able to get away with having no QC on the OCC line, but in a worst case scenario, you're looking at 1 person. We have a hard time, or I have a hard time, ever committing to a hard staff count because of what I said before. The material changes constantly. And when somebody gives you a hard pre-sort or a hard staffing number, they're going to tie you to your material composition that you provide them. You can never guarantee a material composition, so therefore every guarantee of a hard number always has a loophole built into it. So we always try and talk in a range because the material changes and the staffing changes, and that's just the nature of our business. So we have 1 person on the OCC possibly. On the fiber line, we're now looking at a huge change. So we're looking somewhere between 3 and 4 people on that primary O&P line, which is going to be the heavier burdened line. And that's because we've automated the pre-sorting or quality control of that line prior to any of the sorters being involved with the material. On the mixed paper line, we're looking at 2 people, mostly because they're targeting prohibitives instead of outthrows. Now again, the volume of O&P versus mixed paper is something that's going to evolve as the material comes and changes, as the markets change. But again, our O&P screen, like the OCC screen, only simpler because it doesn't have any spacers, we can change that target sizing of the material to allow more material to go over, more material to go through. So there's a lot of flexibility built into the system to evolve with as the material evolves. PET, usually 6 or 7 out of every 10 facilities we have do not staff their PET QC line. We always design a staff position in there, Really depends on where you're marketing your material to, but the majority of our facilities, the PET quality is such that they don't staff the position. And, Mike, Rodney, and Richie saw that as well. I think one of the facilities might have been QCing PET, or maybe none of them, I'm not sure which. Same thing on the aluminum. The aluminum spec is so tight right now from all of the buyers of aluminum. It's mandatory to have one QC person on that line, absolutely. And with the manual recovery of the HD, we're feeling at the percentages and picks per minute, and we've calculated all those numbers out, we're looking at 2 people comfortably handling HDPE recovery as well as doing a last chance recovery. One person would be on the borderline of complete HD recovery. 2 comfortably covers the HDPE, but also allows a little extra labor up there and time for them to go after any of the missed commodities so we can still get every piece of value out of the stream that we can. So we're looking at ratios of 1.33 tons per sorter versus 1.67 tons per sorter as a ratio. And I know these ratios may sound a little theoretical or whatever, but these translate exactly and directly into your revenue. They are your hard expenses. You're currently at 0.55 tons per sorter. And one of the things we really wanted to focus when you guys did the tours was to talk to our customers about what the system they bought was designed and told they would run at, and the staffing ranges that they were given. And I think you guys you toured 3 facilities. We would invite you to tour 30 facilities if you'd like. We'll give you the phone numbers of every one of our customers. We feel that that is a critical aspect of everything that gets put into the market. It has to perform at the rated throughputs at a minimum, and it has to operate with the labor because that's how you plan and that's how you pay for everything. So we look at that as a key differentiation amongst us and our competitors, is that we open our doors to almost every one of our customers. The only ones we don't are the ones who specifically say they don't want anybody coming in. We encourage you to call everybody. Our systems perform at rated throughputs and usually at lower than the expected range of personnel. It's just something that we really take pride in. We do what we say, we deliver what we promise. We've been in business for this many years, 34 years. We wouldn't be here and we wouldn't be the largest if we weren't doing what we said we were going to be doing. So just some overviews. If you've been to the Murphy, you know the pictures of it, obviously. We haven't really changed any of the throughput. I'm sorry, the floor print of the facility. The tip floor is relatively the same. Actually, it's unchanged. Your bale storage on the back end, completely unchanged. We haven't really taken up any more floor space at all. And that was one of the critical things, because you operate right now, and every MRF in the country operates, and they always wish their tip floor was bigger. They wanted more bale storage. They always think the building was undersized. Well, you guys are feeling that way at 10 to 12 tons on average. You can imagine what it's going to feel like when you get to 20 tons an hour. To take up an additional square foot on the floor, to us, felt criminal. We were going to basically increase your throughput by twice and then take away floor space. We felt like that was going to handcuff the operation going forward. So it was really one of the more important things when we were going through different design aspects, was to try and maintain your floor space as best as we possibly could. And we were fortunate. We really didn't have to do anything to your floor space as far as take up any additional real estate. So these are just some overhead views, kind of showing you where the container line is. On that back line, you can see where the incline and the magnet are. That's where your current pre-sort room is, or your container sort room is now. It's essentially just flipping over to the other side. We're not showing the booths, because if we show the booths, you don't really get to see anything. So the model is a little bit modified, doesn't show your sort cabins. And it also shows you now how through the stairs, you've got a PET QC at the top, stairs going down to the manual recovery for the HD folks. And then you can also take the stairs, and then on the foreground here, those are your 2 fiber post sort belts. So now all of your sorters now are combined and in one space. Again, just showing the overall footprint, nothing really changing on the size. And then kind of showing you, we've kept your main fiber separation line and screens. While we've changed all the components, we've kept essentially the exact same footprint. If you guys wanted to see some videos, we actually have videos of other facilities, but also want to make sure you guys didn't have any specific questions that weren't covered by what Mark and I have talked talked about so far.
Okay, guys, it's your time.
I asked the previous presenters the same questions, but basically, we designed this as an RFQ rather than RFP because we wanted your expertise, not our telling you what to design. We just wanted you to produce what would meet our demand. But the RFQ was finite in when we wanted to start, what our budget was, and our floor space. If there was any latitude in any of the three, would your proposal have changed much, significantly?
So I would say that Mark has seen significantly more proposals than I, and I'll see if he echoes what I have to say, but in my opinion, when you give a manufacturer a very narrow scope to work within, you're basically getting the lowest common denominator. When you give a goal and allow us to do what we do, you get creativity and you get the highest common performance of everybody who's participating in the RFQ. So for us, we hate seeing a design in a spec that we're given and asked to quote to the spec. If that's the case, go buy the parts and go fabricate it yourself. What you're paying for to go with us is our experience, the level of support that comes in after the sale, our creativity, our design aspects. That's kind of what you're paying for. The components are they're not small, but they're not essentially everything you get when you pay for a system. And if you don't ask them, the manufacturers, to do the others, you're shortchanging yourselves.
Yeah, I would add, this has really been a refreshing process. Usually municipalities are not this thorough, and the more thorough you are, it leads to correct decisions. That doesn't always mean that we end up winning, but it leads to correct decisions. So we were talking about that in the car on the way here, the thoroughness of the process. Speaking directly to your question, sure, if we had a different building or a blank piece of paper, we could have designed or would have designed something different. However, to me, it's a balancing act. So there is a amount of capital that you would spend versus the output of material versus number of sorters that you would need. And to reuse your existing infrastructure and then just add a new screening package, in essence, if we went back a slide, that's at least what we tried to do, is reuse your existing infrastructure, dumb steel, as they say, platforms, catwalks, bunker walls, reusing all of that, and then just adding new technology. Obviously, we're not privy to what the others are quoting, but we think this is the best retrofit process for this size system, and we feel confident in it. One thing that I know the MRF might not be second nature to a lot of you in the room, but the fact that we were able to fit an optical sorter directly after the main fiber screen without having it to interfere with where your existing human sort line is, that fits very nicely, and you didn't have to expand your building. So I would say this is a really nice scope, and we would be fortunate to have the project for sure. Did that answer your question?
Yes, thank you.
What's your time frame to get the work done?
I had to look at the bid, but I think it's 8 months from the time you order. But while we're on site, our crew would be here for 40 days. But that doesn't mean you're down for 40 days. There would be times where you would give us the plant for a long weekend or a stretch of 3 to 5 days, well pre-planned in advance. But there would be a lot of mechanical work done that doesn't affect your operation within that 40-day window.
So on the 8-month aspect, that's our standard length lead time. We weren't asked to expedite it at all. If you have a hard date, we would be able to tell you relatively quickly whether or not we can meet a hard date if you had something shorter than that. But without a specific target date, our standard lead time for this type of retrofit is in that 7-8 month range. Yes, sir.
I come from a background in the automobile industry. General Motors, Ford, Chrysler, they don't make their frames, they don't make their chassis, they don't make their fenders, they don't make the motors. They don't make the windows, they don't make the doorknobs. They get it all from contractors and subcontractors. Do you manufacture your own frame, chassis, windows, and hubcaps, or do you get them from some other supplier and put it together as an assembly?
So I'll answer that. So we're unique compared to your other vendors. We are a master distributor of best-in-class technology from around the world. So we're using factory primarily in Europe. The Tomra factory makes our optical sorter. The Bolograph factory makes our conveyors. The Lubo factory makes our screens. And we put all of those together, and we're the system integrator and the system supplier and the servicer after the sale. But we work directly in concert with those factories. And yes, if you were to take a tour of those factories, they're actually, for the most part, doing weldment work. They're doing everything right there in that factory. Obviously, they're bringing in rubber for the belting and that type of thing, just like a car would bring in tires or whatever.
But they're cutting and fabricating steel.
Do you charge for software upgrades?
We do not charge for software upgrades, and that's a great question, and that is more and more prevalent as your technology ages. Look, we also don't charge for phone support. So what we say is, if your guys get as trained as they can, it helps everyone out to be able to call in, talk to someone. You'll have a modem connection, so our guys will be able to look right into to your PLC. So that's a good question, but no, we do not.
You'd mentioned that 99% of your parts would be available. Is that in North Carolina?
No, we stock all of our parts in Norwalk, Connecticut.
In Norwalk.
And we are able to overnight and or courier. I think we have 12 different methods of delivery that we offer. So basically, if you call before, we say 5 p.m., which is the last UPS pickup, we can have it there the next morning at 8:30 a.m.
Does the optical sorter you use have rubber discs?
Well, the screen we use, the primary news screen, which we call the 440 screen that doesn't wrap, it has rubber. The optical sorter was the orange box that hovers over the belt. So it's a box looking down, and then the conveyor conveys the material, and then there's an air bar. So it doesn't have any, other than the conveyor belt, there's no rubber associated with it.
Was that the ballistics that had it?
Yeah.
What they call in their 440 screen has it, and their OCC screen has rubber discs.
Okay.
And metal as well.
Ms. Pam, what I'm assuming you're referring to, the number one culprit of every MRF in the country, all 400 of them, is replacing rubber discs, replacing rubber stars. I'm sure your facility is no different than that. So let's just take it screen by screen. The first screen, Jeff, you want to point out where the first screen is? The first screen is the OCC screen. Here, it's a flat, primarily flat screen. It's going to take the cardboard out. It is made of rubber discs. You almost virtually never change those because the deck is flat. The next screen is steel star glass breaking screen. It's going to break and screen glass. The next screen, that's the screen you're talking about. That one has a steep incline, and that's where the wear occurs at every other facility in the country, and ours is no exception. So that one does have rubber discs. The good news is, since we showed you the shaft is so much wider than previous shafts, and really wider than the shafts you have, there's not that many stars on there. There's 128 stars, and the life of them is longer than a traditional screen. So You do have to change those 128, but you have to change them once a year rather than once every 4 months or once every 6 months. So that's
Stars wear out. If you've seen it, it's a rubber star. Sorry, if you've seen the stars, it's a rubber star, and it looks like a star because it's got fingers on it. Well, if you can see when a system gets wrapped up like this, it's the ends or the tips of the stars that rub against the wrapped material around the shaft that it's opposing. That material gets built up, and then that tip of the star continues to rub and rub and rub and wear, increasing, or I should say decreasing the life of that star dramatically. What we've seen is 15 to 20,000 tons is what you can generally run over an old style screen like that before you get significant wear that pretty much precludes you from getting any efficiencies afterwards. And Richie might be able to change the number a little bit based on what you guys are seeing here on when you change your stars out. But it's usually in that 15 to 20,000 tons over a screen when it starts getting some problems. What we've seen by reducing that wrapping with the new design, we've got systems and customers that you'd be happy to talk to. They're running, one of them in Pennsylvania, which is one of the first ones that went in. He runs roughly 60 to 65,000 tons a year. And he went an entire year without changing any stars.
What's involved in replacing them? Does it take one?
2 bolts.
One person?
One person, 2 bolts.
2 bolts.
Yeah, you don't have to pull the shaft. You can change on the shaft. So I want to go back just so we're clear on. So after that screen, and so it's 128 stars, and those are rubber stars. But keep in mind, that's how you're getting to 20 tons an hour throughput. We could put a ballistic separator right there, and I could tell you, oh, you'd never have to change stars. You'd have a ballistic separator. You're never making 20 tons an hour. Having a ballistic separator as your primary fiber separation device, you will not make your throughput goal, and we can't risk that. If we're going to give you a guarantee of 20 ton an hour, you've got to have a non-wrapping screen there. Then we go to an optical sorter, no stars on that. Then we go to a ballistic separator, elliptical separator, no stars on that. That's the paddles that you saw in the caricature. So we do have one screen that you have to focus on, but how that would compare to what you have now. Right now you have one news screen, and the V screen is also known as a commingled paper separation device. That commingled paper separation device, and we still supply those as well, not ours in the V, but that thing has 400 or 500 stars on it, and it's very sensitive to wear, meaning you have to change it more frequently. So that's the screen that really starts to add into the dollars. That's where the dollars of month after month you're having to buy stars.
And when we talked about earlier in the presentation, we have a focus on how we go about achieving your goals. And it was, one of the points that we had up there was on your maintenance and operations budgets. We knew the primary thing was we have to hit throughput, because after you just need, the material doesn't stop coming, it has to get processed. So throughput's obviously our primary focus, which is why we went with the higher volume processing type screen, which is a rotating shaft. But 2 points down was on the maintenance of the overall system. We also understand you have to make money, and we can't just lard it up with high wear and spare type of equipment. We looked at it as a balance. We make a ballistic separator. We can change the sizes of the ballistic separator. We could put 5 ballistic separators in them. It goes into a balance. It takes up more footprint, more space. We're now looking at throughput issues. Okay, we could do 2 side by side and then maybe get to the throughput. But now that we're taking up floor space, we're taking up more equipment, more motors. We look at everything as a balance. You know, you move one piece and 3 others change. To us, utilizing the technologies in concert gives you guys the best result.
That's why we defined it as performance rather than.
How are you going to integrate your system with what we have now, the electrical system and everything that's up and running today?
So we were asked to provide you guys an estimate, or I mean, not an estimate, but a quote, to not only change out all of your controls, which we've included, so you'd have a completely new set of controls, but we were also asked to provide a quote for rewiring, hardwiring, and changing all the conduit for the entire system as well. And we've provided that quote as well. It's in the addendum that we submitted.
Jeff, talk to us a little bit about the life expectancy of your optical sorters?
We've got optical sorters that are operating now 15 years, 16 years. They're still up and running.
03 was our first year to supply a Tomra or a T-Tech optical sorter. Some of those units are still in operation today.
Perfect example is Republic Services. They just shut their facility in Sarasota, Florida. It wasn't our system, but they did have one of our optical units. That optical unit's 13 years old? Maybe minimum of 13, maybe 14 years old. They're in the process of packing it up and moving it to New Orleans to put into a system that they're starting up in New Orleans. So from a life cycle standpoint, if they're maintained, I don't know why they would stop working.
Yeah, the beauty of, and obviously the beauty of everyone's that you're also talking to, not just ours, but the technology hovers the belt, so it never comes in contact with the material. And that absolutely helps prolong the life, for sure.
What maintenance issues have you seen with them? And if so, idea of cost?
Yeah, this is a concern, and that would be a concern for every supplier. This is just advice to the plant personnel. They need compressed air, so you put in a fancy air compressor, basically. That air compressor needs to generate clean air and needs to generate dry air. And if it doesn't generate clean and dry air, it affects the MAC valves, the air jets. So if moisture gets into those air jets, you have to replace the air jets. Basically, we give a spec to the drying company, or to the compressor company. So it comes as it should, and it's usually not an issue. Where it is an issue is if your compressor goes down, and we've seen this time and time again, and then you go out to the local Ingersoll Rand dealer and rent a compressor, bypass the drying system, and you lose every valve. That is very common if you were to do the rental thing. So the valves are sensitive to moisture. But keep in mind, we only have one lamp for every 4 feet. So your big unit that we would have, you would have 2 lamps in it. And your small unit, you would have 1 lamp in it. Then there's a spare. So you're not changing 120, 200 light bulbs with the competitors. And there's also other benefits to that, meaning we don't need a dedicated air conditioner like others do, because we're not coming with all of that extra heat from the lamps. But as far as durability, there's 2 customers to call if that's in your mind. The first customer that comes to mind is Mohawk. They make carpet. They're in northern Georgia. They've had this unit running in a 24-hour day,
7 days a week,
7 days a week, 4-shift operation for 4 years now.
They take it down, I think, once a month for maintenance.
And they've had very stable, no issues to report, gone years without changing even a valve. And the other one is Sims, which Jeff started to show that video. That's another 24-hour day operation that went live in 2013, or the beginning of 2014. So that's got 24-hour days worth of operation going into its 5th year, again, with virtually no issues. And look, you can take the 2 sales guys' word for it, but that list is available. If you want to call anybody, we can give you the full list of our optical sorters. And keep in mind, no disrespect to our other 2 competitors, we have over 450 of these optical sorters. 450. One of the competitors that came here today has less than 20. So keep that in mind. When you're asking how long do you think they're going to last, that's a hard question to answer if you've only been making it for 2 years. We started partnering with the company Tomra and T-Tech in 2003. They started making them in the mid-90s. So we've got a lot of experience with the optical sorter for sure.
Okay. Thank you. Any other questions?
Well, I'll just beat the dead horse on the timer one thing. If y'all have eaten at McDonald's, you've utilized timer technology. And something like 90-something% of every French fry that comes through McDonald's was optically sorted by Timer's food division. It also has a mining division that looks for diamonds and rare earth gems and stones and things in the mining industry. Potato chips. You come into contact in a daily basis with our technology that's going to be in that optical unit. It has, if it's in the food industry, it's got to be stable. It's got to be reliable. I mean, you can't have technology that's not, to that sort of level. It's one of the nice things we have when we're able to partner with these different companies is that they've got huge R&D budgets and they're in different industries, and we're able to pull what they're able, things that they've been doing for 2 decades in the mining industry or the food industry that we've never even thought of in the waste industry. And we're able to kind of piggyback and pull, well, that's a good idea. That's a good idea. And we're starting to pull these things back into our side of the business, and we're not having to learn it. We're basically borrowing it from these other industries.
I'd just say, really appreciate the time you've given us, and it's been a really good process, and I wish other municipalities would kind of take your lead and use this as a model. It really would make the whole process a lot easier, for sure.
Very good. We appreciate you taking the time, come sharing the information with us. Great.
You want to take just a minute?
We'll take just a minute to then,
Get their stuff sorted out?
yeah,
All right?
take a 5. 'Cause you only got 20. Comments from you before I? or anybody?
No, we've looked at a lot of good proposals here today, I think. A lot of good ideas. Some we like better than others. We got a budget to work within, and staff will do the best they can to stay within that budget and do that budget, because Jan's gonna make sure.
But that's my
And-
Jan's here.
And so we just got to kind of get the best system we can with what we got, and we're going to work on that vividly for the next few days.
And you're going to have it ready for the 22nd?
We'll have it ready for the 22nd.
Right.
All right. These are what I brought, that I got out of all this meeting for the last 3 hours. A lot of the equipment is similar, probably do some of the same kinds of things. You guys are the expert. I don't spend much time at the MRF. But these are the things that come to mind that I would like for you to look for, that maybe you can answer, so that when you bring that proposal to us, these questions will be answered. Number one, we talked a lot about downtime and uptime. We need to know what are the equipment, how it reacts to downtime and uptime. We need to know maintenance costs or repair costs of the equipment. We need to know the efficiency of the equipment based on the presentations that you have seen. We need to know manpower replacement, how this equipment may or may not replace men. I want to know the quality of material that's coming off, whether it's going to be equal or better than what we already have. I'd like to know the longevity of the piece of equipment, whether it's 7 years, 15 years, or somewhere in between, where we can make some kind of proclamation of how long it's going to last. I don't want to buy a piece of equipment that's going to last 1 year. I need to know the best fit for the building that we have over there. So when you're looking at this equipment, we need to know what the best fit would be. Future technology, I need you to find out if there's anything that they have that they're looking at that may be available within 1 year or 2 years. One guy said that they didn't offer that, but the other ones. Capacity of equipment, that's something that I never heard anybody talk about. Will it do what we want now, and what will it do in the near future? Because we don't need to buy a piece of equipment that may not do what we need it to do now or sometime in the near future. Installation time, we need to know how long we're going to be down and how that's going to affect our operation. And any accessory services, for example, a lot of them talked about software and update, and if there's anything else as far as guarantee maintenance time, how long does a piece of equipment, what is the maintenance on it? And naturally, the last thing goes back to, Jan, the cost. How does all this fit into the budget that we have to buy and replace what we need? That's my list. Anybody else got something they need to add?
Just two things. Some of them discuss the arrangements of these machines and how it worked better. You would know that from going to look at it and how you do it. I think the last ones did, that you should do it last, and it would eliminate certain things, and that would help it do that.
He was right, Ms. Creech, in the point that the ballistic sorters have a per ton restriction.
Right.
He is correct in that, but there's ways of redesigning it otherwise to take care of that.
Okay, I just wanted to make sure that all of their input on how it was arranged and how much better it worked and the efficiency and so forth, that we could arrange whomever's equipment to fit that. And the other was, how will we handle guarantees? The last two gentlemen kept saying they had to do certain things to guarantee what they were telling us they would do. I like that. You know, I realize you might not be doing exactly the same thing at the same time, and you have to look at those. But I like somebody talking about a guarantee, and frankly, I'd like for them all to be able to come close or either guarantee what option they would have or they would give us if they didn't to what they're telling us.
What typically happens in those things is that you get a contract with a company and you hold back a certain amount, usually 10% of that money. And until, in that contract, you have throughput standards and reject standards. And they have what they call commissioning the equipment. And when they commission that equipment, they have to meet those standards to get that money, which is part of their profit. And that's
would be a part of the
typically,
contract.
yeah, so it becomes part of the contract. You can say what you want to, put it in line, but you got to do here to get you in payment,
The final payment.
final payment.
Now, did they, I know two of them in the first, proposal that they submitted, they were looking at 16 tons. The capacity was a whole lot less than what you asked for, right?
That's right, and we
All right,
corrected
now-
that through the second proposal.
Say again?
We corrected that through the second
Right,
proposal,
okay. So what did you move it to?
18 to 20.
18 to 20?
It probably goes without saying, you didn't put in your charge to him, but we need to manage our downtime. Does that mean sending our material outside the county to be processed?
Yeah.
You did, okay.
That's one I put downtime versus uptime.
Yeah.
I would hope that we'd have more uptime than we have downtime.
But there are
So I put vice versa.
There are other ways
I
to
need to
manage
know,
that down.
I need to know both of those.
There are other ways to manage that downtime.
Yeah,
You
right.
could-
You,
One of them,
go ahead.
one of them was making everything new. The other two were mixing old and new together. That doesn't work as well usually for me when I'm trying to scab something or add something to or use something old. It'll always be old. It'll always be an age difference there. I like everything being new, and I like the fact that that one didn't have any rubber discs or stars in it to replace.
Okay, going on down the line. Carl?
One of the things I was interested in is what's their support policy? You know, sometimes you can buy a car and next time you go in, the dealer will take care of all kinds of things. Next time you go and see the dealer, they charge you for, just showing up, so.
All of them had free telephone support.
Okay.
If you had to have somebody on site, there'll be a charge. But I'd probably say 90%, I said two of them. Two, all of them have free telephone support, is what CP said. For the optics, right. But CP Manufacturing charges a per hour charge by the phone. Two of them has telephone support. One of them does not, and one of them has training capabilities. So there is some cost that we're going to have to be taken into consideration when you're looking at those things, along with warranty.
Now, the warranty's not the same either, if I recall correctly. One was a year, the other one was 18 months, right? Or were they the same hours?
They were all a year,
All
except for one, there was an additional charge to go to 18 months, there was an additional charge to cover it for 18 months.
Did they increase the hours, or the hours stayed the same? They just increased the
I don't
time?
remember the answer to that question. I think maybe the hours just about went up. Richie's the one who looked at all that, but we all get together, get in the room.
If I remember correctly, we had 3 different systems here. System 1 had all stars or the rolling discs. System 2 had 2 ballistic sorters in it, and then System 3 had a roller disc with a ballistic sorter. Is there any preference there to the staff?
Well, I'd prefer one that had less maintenance costs, long-term maintenance costs. And once we put the numbers there, we'll look at it.
Because they wasn't, they were achieving the same goal, but they were completely different machines there.
Share with them, Mr. Jones, about the,
And then, I got one more question here real quick. The, on the last machine with the Van Dyke sorters, he put the system in the front to get rid of a lot of the cans and PET and HDPE, he said, while the other machines was letting it flow through the whole system. Do you have a preference on that? Because that sounded like a good idea.
All of them, the first thing gets rid of cardboard.
That's right.
The second ballistic or rubber screen separates all the newspaper and drops all the bottles and everything else down. Then that goes to, what he did is went it straight to an optical sorter where everybody else is carrying it to the second screen before it's going to
Correct.
another one.
I thought that could be possibly a good option, but that would have to rely on staff and what y'all think, but
Yeah.
something to think about.
There's things about all the companies that we liked.
Yeah.
The question is, what can we afford with what we got and get the best piece of equipment we can get?
Those are my first 2 questions. What are the costs and how much is it gonna save us?
Yeah.
That's my first
Well,
two
I think if you go down this list, what you're gonna come up with, and they'll have to do all of this, is find out what our return on investment is. What are we gonna get for what we pay for? And that's what I'm taxing those guys for, because I don't know. I'm leaving that up to Mike's staff, but he needs to look at all of this so that he can make that determination. If you have reduced maintenance, if you have reduced manpower, if you have efficiency, you're getting the same quality, then we should have a better piece of equipment that's gonna give us a better return on investment. Those are the kind of things that he'll have to look at to see if it matches whichever vendor he feels more comfortable with. Go ahead, Stan.
Bo kept asking if there was, if we waited a year, would there be new technology and stuff come out like that? If we don't get the piece of equipment that you feel is necessary, I know in my business, I like to buy what I feel will work the best. I mean, and in this situation, I don't want you to compromise the possibility of spending the money if we can wait another year and get what you truly need, if that's feasible or the money's feasible.
Well, I think this is where we ended up.
Or do we got to have it right now?
These guys spent 4 days, actually 8 days,
Yeah.
actually going around looking at these pieces of equipment that actually work, and has made the determination that what they've seen and the way they work would be conducive for what we need. And that's why we had a new RFP to signify exactly what they want, and this is what these guys were doing. And that's why I invited you in, so that you could see what the process, because this RFP is different than what they originally thought about. That's why we've been in this for 6 months. So we're at the end of the road now, so we need to get, I think we've determined what we want. We just need to determine which one of these vendors will be able to provide that based on the amount of money that we have. And
Yeah, they gave us one proposal, and once we had our mindset thinking that's what we needed, You know, when they gave it to us, when we left here, we had a pretty good thought process. Well, this is what we like. And by the time we got through the whole system, we'd done changed our whole thought process, which was, like, it was good, because the things we thought worked certain ways didn't.
That's why the standards of meeting what our requirement is, not designing the system for them, make perfect sense. But the contract ought to read the same way. The warranty ought to be to manage the output that we want, not that their system maintains other standards.
Right.
We want to meet our requirements.
I'm glad that you took the road trip and you actually looked at how they worked and talked with the actual people that worked with it. That's not surprising that you changed your mind, because a lot of what these guys are selling doesn't work exactly like they say.
Well, you know, we didn't invite any sales reps to go with us. Any place we could get into that didn't allow us, and they gave us a list of companies, and we didn't necessarily choose those companies to go to. Richie got on the internet, and he found places, and I called people I knew in the industry, and we went to those places. We didn't go where they wanted us to go. We went where we wanted to be.
I think that was a good gesture, and I think you came up with a plan, and so I'm gonna leave it up to you and your staff to put together a recommendation for us on the 22nd, based on answering the questions and looking at the vendors that you have here. I assume you chose those vendors because they came closer to what you were looking for, and you thought maybe that they could produce what we needed. So, I don't have any questions. Anybody got any other question? Get them in. Now's the time.
Let me,
We got our
Go ahead, Danny.
meeting, so
Oh, we won't deal with that one when Danny's finished. Go ahead.
when we make a recommendation at the meeting, these fellows' jobs are just starting. A lot of these people that have got up spoke today have been here many, many times, spent a lot of time at the MRF, on first-name basis with them. And I think the trips were well worthwhile. But as one of them said, if you had more money, he could offer you more equipment. But I think the concept, the way we put it together, was very unusual to them. And I like the idea that they said, well, the way you put it together, you utilize our company's expertise on what you could have and what you could use. But coordinating this thing, getting it installed, stacking stuff up, getting it out of the way, yeah, you could shut it down for so many days, but you can't afford it. I mean, you can't afford the weekends. I mean, it's thousands and thousands of dollars higher than just doing the 10 days and getting it done. And we know they say we can do it in 10 days, and you hold your breath on that. Something won't come in, or they won't have a connector or something, but this has been a heck of a process, and we just hope we can answer all these questions that's been laid out. And I know once these guys make the recommendation, they gon' believe in the recommendation they make. They've seen it, they've felt it, they live in it. And what we've been through the last 4 years at that MRF, and what they've done, and what they put up with labor, with me, with I&R committee, with everything, it's amazing that some of us lived through it. And we know Charleston's not gonna re-up. We know that's a pretty good deal, and we're working real strong with them to where they get the dregs balanced out and get them back to wherever they're gonna take them. So, it's been good for us. We made money. But we got more material now than we've ever had in the county, so, and we're gonna push for more. So, good luck to staff.
Okay, if you have any other questions or you think of any when you leave, either give Mike or Danny a call. Pam brought up a real important point. I'm looking on this schedule here that Esther gave out. January 22nd is scheduled for our board meeting, and that's the same night that they're doing county council. And we don't know if we're gonna be on the docket for,
Well, that'd be good if we can't go, won't it?
We'd have an excuse.
Well, we could have the board meeting at 1 o'clock, or,
it's up to you guys.
Yeah.
You know, I don't usually attend a whole lot of the county council meetings because they probably lock me up. That's why I don't go.
I'm
So,
protesting all meetings at 6 o'clock because the bridge is out.
so for those of you who really like going to the county council meeting, if we want to change this date or push it up or whatever, I'm gonna leave that up to your discretion.
How about we do 2:30 or 3 o'clock, and that gives you time?
yeah, I mean, I don't go to county council meeting, I just occasionally may watch it on TV, but, I mean, I don't.
Somebody told me they saw you there every night.
No, hey, I tell you, when I walk out.
The last 6 years.
Anybody wants to go to county, before we change this,
Okay,
let's see if there's any need.
all right, that's a very intelligent decision there. Pam wants to go.
Yes, I do.
Pam wants to go.
If they have our 3-year plan discussion on there, I think that some of the
So,
staff
yeah.
would need to go.
Now, and the plan is not on there for Thursday. They're
No.
having a council meeting Thursday night.
Right.
It's not on there then, but
Before we do that, you can change it. If it gets on there, change the meeting whenever you want to.
Well, just,
Yeah, but we can't, we have to advertise the time and that kind of stuff.
There will be time, I believe, when that
I don't know.
gets out.
Where's that to
don't-
go? How much time
They
we
don't put
got?
out the agenda until
But
Friday.
why we can't, I like to finish it while I got it started. So let's decide, how many people want to go to the meeting?
I'll watch it on TV.
well, if the plan's on there,
We all.
many need to be.
Let's do this. How about this? Let's do an executive decision. Let's move it up to 2 o'clock on the 22nd.
I second it.
All right. Let's just move it to 2 o'clock. Because I'll be here all night trying to get some dates.
January the 22nd, 2 o'clock.
Dan can tell you how long it takes to get to that side of town.
Yeah, that's right, because we got to get over that side of town. So we'll have a short meeting. We'll do what we need to do here, and we'll be out of here.
Yeah, because
No, we're
the George-
Yeah, that's right.
Do you want to address the February meeting?
Oh, in February, what's happening in February?
The trade show in Orlando is the same day as our board meeting. It's the 24th to 26th, and we're meeting the 26th.
Yeah, we do have time to address that one, don't we? Okay, let's address that one on the 22nd.
22nd.
Okay? We got time for that, because I don't know how many people planning on going to this, wherever we're going. I hadn't even looked at it, hadn't had time. All right, anything else? All right, I'll ask for a motion to adjourn.
So move.
All right, we are adjourned. Thank you.